The other thing, we're looking for somebody to organize plant swaps. So traditionally, we've had a fall and spring plant swap, and if you're interested in maybe doing that after the Master Gardener meetings in November and May, Alex Friedman can help you organize that. Um, the slate of board members was supposed to be shared today, but we've had some wrinkles to that. Ken Hoyle has stepped back from treasurer because of family obligations, and so Sue DeGrabba has stepped into that position as treasurer. And that means that Sue's position as second vice president is open. We have somebody who has volunteered to do that, but they have not been officially approved by the board. The next board meeting is on Thursday. So that will happen. And as soon as it happens, we'll get the slate of officers out to you. And then we'll vote on them in November. So please check your groups IO. Please make sure you read the seed at the beginning of November, and it will have the slate of officers so you know who you're voting for ahead of time. And my last announcement has to do with nominations for, I'm sharing my screen, uh, has to do with nominations for outstanding service. Can you all see that? Continue to share, yes, okay. Um, so this has to do with Outstanding Service Award. It's an award for anybody that goes above and beyond the call of duty. And it could be any master gardener, and anybody can nominate them, a master gardener or intern. And I just need to know who you're nominating and a brief description, a couple sentences of why you're nominating them for the award. And the awards are given at our holiday party in December. And then there's the Lifetime Leadership Award. These are for people that have 15 years of service or more and have done a substantial amount within a committee, or maybe they've been on the board, or they've been a committee chair. So they've done something substantial in the 15 years. I need the name of the person, and again, a little paragraph telling me about why they're receiving that award. They can only receive the award once in their lifetime. And the award is given at the December holiday party. So all of this information is in the seed. It's also gone out by Groups IO. So the information is there. And the people who just got 15 years of service, their names are there. So they're eligible to be considered as well. So what do I need? I need a name of somebody you'd like to nominate. I need a little information about why you're nominating them. If you can get a picture of them, that's even better. And nominations are due by November 1st. And you see my email address right there, lamabean290@gmail.com. So please, please, please send me your nominations. Okay, I think that's all I have to share today. And so I'm going to give it back to Steve to introduce our first speaker.
Eva Monheim, our first speaker. So um, I guess it was Eva, I think I heard your presentation when I went to the Chessie Green conference. And so I thought that was a very interesting topic. And so I've asked Eva to come and speak to us this morning. So a little bit about Eva's background. Eva is an award-winning speaker, ISA certified arborist, award-winning educator, a faculty member at Longwood Gardens for the Professional Horticultural Program and Continuing Education Department. She is an assistant professor at Temple University, where she's taught 13 different subjects to undergraduate and graduate students in horticulture and landscape architecture. Lisa's other endeavors are award-winning uh, uh, the Plant a Trillion Trees podcast, which is heard in over 110 countries. She's an author. Some of her have written many books. One of them, World's Most Popular Plants, which has been an award-winning book. She's also the co-principal of Verdant Earth Solutions, a company that writes educational documents and standards and SOPs for landscape management plans and trains professionals in the green industry. Verdant Earth Solutions provides garden and landscape consulting as well. So it's my pleasure this morning to introduce Eva to speak to us. So Eva, I think at this point, I'm going to switch it over to you.
Okay, and I'm going to pull up my presentation. Thank you very much, Steve, for inviting me. And first of all, I wanted to say that the Master Gardeners can never be replaced. I just want to, I always like to say that volunteering, just people just don't understand how much goes into it. And I have to commend your organization for all the work that you all do. So thank you for all the things that you do for your community, because it's huge. So I just wanted to mention that. Um, and let me just get this into the right frame here. And this talk came about for several reasons. One of the things that I noticed in driving is all the dead deer and raccoons and possums, and when I guess it was back in the late 90s, I had asked the state of Pennsylvania how many deer are killed on the road a year, not counting possums, not counting raccoons. Over 40,000 in Pennsylvania. And I thought to myself, that's crazy. Over 1 million across the country a day, animals killed on the road. If it was humans, we would do something about it. But because it's animals, we don't. And so I thought to myself, what kind of backlash is this causing? And a lot of this is related to seed dispersal, because animals carry seed on their fur, in their paws, in their excrement. And if we have the roads blocking or on the major migratory trails of animals, this would actually impede them from being able to move and carry seed. So I started looking at the flyways for birds, and then I started looking at our roadways for how our deer and other smaller animals travel. And there was a huge visual that I put together, and then it was actually confirmed through various sources, and I'm going to bring those up in a minute. But I just wanted to give you a little bit of background about how this happened. And the other thing is, I used to have a wolf hybrid, and he was wonderful. I got him through a native tribe, and he was incredible to walk. And then one day he had this little limp, and I said, well, let me see your paw. So he lifted up his paw, and in his paw, because his paws were so big, he had acorns stuck in his paw, and he wouldn't let me take them out. So I let him walk home, and he's still hobbling around. But as soon as he got home, he had sat down and he started pulling the acorns out and eating them. And I had never seen him do this before. So I thought, wow, animals carry acorns in their paws and they use them to eat. And that just blew me away. And I think to myself, well, how many of you have ever seen an animal pull seed from their paws and eat it? So anyway, here's the US annual temperature change since the 1900s, the early 1900s, all the way through till now. And there has been a 2-degree difference in temperature through our regions. So this is another thing that has changed how seed and plants move, temperature change. And you'll see that it's cooler in 1901 to 1930, but then we start to escalate our temperatures clear across the country until we get the map that we have today. So this is another drawback for our plants. But then I saw this map and I just was blown away. by the similarities between our major roadways and animal movement. And yesterday I had a class at a garden, and the one woman was telling us about the road outside of her home, which used to be a Lenai Lenape trail, which is now a major highway. And I thought to myself, okay, so what we've done is we've made highways out of the original trails that the Lenai Lenape took, but the Lenai Lenape Indian tribe also used those roads that the animals created to traverse our country. So here is migratory trails for different. No, this is not all of them. This is just a tad of them that have been documented nationally, and along the East Coast, pretty much, is 95, Route 95, and on the West Coast, it's the 101. And then in the central part of the country, we have other roadways that intersect these trails as well. So we're looking at migratory trails, we're looking at regular animal trails, but we're looking also at butterflies and dragonflies. And I had no idea at one point that dragonflies migrate in huge masses. And the other thing that migrates dramatically are ladybugs. And most people don't know that either. And I picked up, I was in California visiting my son in LA, and they were talking about this cloud, this red cloud that appeared over the southern part of California. And the weather people sent up a helicopter to see if they could find out what in the world kind of cloud was this orangish red cloud. It was ladybugs that were migrating, causing this huge cloud in the sky that weather people had never seen. But it was because the weather had changed so dramatically that the ladybugs couldn't stay in that area because it was too hot. So they moved to cooler location in the mountains. Wow, blew me away. So these migratory trails are critical for animals, but also for humans too. So here's 95. And if you think about this, the roadway is one solid mass all the way down, and there's very few cross ways for animals to get across. There's some bridges underneath, like they're raised, but there's usually a road underneath. So that's another thing. Not all animals will go over a bridge, but they will go under, especially bears in particular. So I wanted you to see this, how we've kind of impeded animal movement. So in all of this, we think of the temperatures that have risen. The temperatures have risen because of roadways that we've built, because of things that human activity has caused. But also, we have seen these changes, and in my lifetime, in 40 years that I've been in the industry, I look at this and I say, oh my gosh, this plant has disappeared from the area and this plant has disappeared. Well, two plants in particular, the mountain laurel here in Pennsylvania is our state flower, and our state tree is Tsuga canadensis, which is the hemlock. And they're disappearing from our region, but the reason why they were selected as a state tree and flower was because they were found in every county. They can't be found in every county anymore because of climate change and because of our rising heat, and the diseases that come with that have obliterated a lot of the populations that used to be here in Pennsylvania. And the same thing in Maryland too, because we have those close borders that we just have plants that will traverse those. Plants don't know boundaries, so they cross over. And there's the Laurel Highlands in Pennsylvania, out west in western PA, just at the end of the state of Maryland. You'll actually see this beautiful area where you can have a tunnel of mountain laurel still there, but the heat in the east has pretty much moved it away from our area. So I look at mountain laurel, and this is an important plant for deer to browse. So now that we don't have mountain laurel here in our area, we have them browsing on everything else. We cut our grass so low that there's nothing for them to eat. They like to pull on their food and leave munching teeth marks. But if you know how an animal eats, you'll change how you mow because of that. So these are kind of things that I think about all the time. But also was in the floral industry, and mountain laurel was a key green that we used to use years ago for making funeral arrangements and doing large scale arrangements. We didn't bring things up from Florida. We actually had local foliage that we would use. So what have people looked at to replace our mountain laurel? We've looked at Alyssum floridanum, which is an understory plant. It has evergreen characteristics, just like our mountain laurel does, but it obviously doesn't have the same type of flower. But it can fill in that void of evergreen in the understory, which is something that you have to have in order to give you the layers of woodlands that are critical for bird and animal protection. And here is the plant. I'm sure you're all familiar with Alyssum floridanum, and it's the Florida anise, and it is quite attractive, except it doesn't have white blooms, it has burgundy blooms. And here it is in one of the locations that I was visiting, and we have it also at Longwood Gardens, and they have been using it as an understory plant. Another plant that's disappearing, and you could probably attest to this, is Picea glauca, the white spruce. We have very little white spruce left in our region. And in fact, the last one that we really see is the dwarf Alberta spruce, which is a white spruce. It's a variation of the species, and it's not doing well at all. It has needle cast disease. And also needle blight, which affects it. And here's a good example of it. In fact, in the neighborhood where I live, I walk, and I'm northwest of Philadelphia, so I walk a lot, and the one whole driveway had this white spruce, and they were all standing skeletons with no needles at all, just dead trees. What they're replacing it with is Abies concolor. We see this used a lot in replacement. If a community needs to have evergreen, a certain percentage of evergreen, they'll use Abies concolor. And of course, this is a Western plant brought here to the East, which is actually filling in a void that we have from the loss of that tree. It has a similar characteristic to it, a pyramid form. It does have glaucous colored needles, so that there's some type of protection for animals in the wintertime. And this is it at Longwood Gardens. And Longwood Gardens have had it planted there for many, many years, since Pierre DuPont was there back in the 50s, and when he bought the garden, I think it was in 1912. They planted these on Conifer Knoll, and this particular plant now is a very popular Christmas tree. The white spruce used to be, and so did some of the other plants that were popular Christmas trees, which we can't grow here anymore. So concolor fir was moved to the east for that purpose too. Our Pinus strobus is disappearing because of decline, and also because we've brought ribes back into our area, which causes white pine blister rust. And so we're looking for other things. So what we've gone to, these are the white pines. The one in the picture on the right is the fall foliage falling, and beautiful cones. But we're looking at Longwood Gardens. We're filling in with Pinus flexilis, the limber pine from the West Coast. It has it's another 5-needle pine, used in a similar fashion as our white pine, but it is much more resilient in its character, and it also helps to secure maybe the remaining white pines that are still around, so that it's doing more of the heavy lifting. And here it is at Longwood Gardens. And when I say they're planting a lot of it, they're planting a lot of it in place of white pine. Pinus wallichiana is another one that they've been using because it can tolerate our warmer temperatures. It's another 5-needle pine, and the 5-needle pines are found in the latitude all the way around the earth in the same place. So that's where you'll find them. And they're using 5-needle pines, again, looking for other sources of plants to use. And here are Pinus wallichiana on the Temple's campus. And the cones are really big. Now, remember that the seed is critical for food sources, not only for large birds, but for smaller birds too, as long as they can get their beaks around that seed. So, and also for small little animals on the ground as well. Quercus rubra. Here's a really crazy plant. When I say this, I say it in very endearing, that this particular plant is suffering dramatically from Xylella fastidiosa, which is the leaf scorch. And I was working on a project at the university where we were checking the trees for Xylella in the city. And I worked at the Montgomery County campus, which is northwest of the city. But if you go further into the city, you'll see that the Xylella is a really critical disease. And here's just to give you an idea, the students were grabbing some of the leaves so we can use an assay to see how bad the diseases were. And it was killing off the trees. Every 5 years, 15% of the population of trees in Philadelphia is gone, because that's how many red oak subspecies are being affected by this disease. So it's something that you really need to think about. And of course, the acorns is a major food source. You have to fill in that gap. So what we did, and here's a tree that died from it, and it affects the vascular system. Macrocarpa, Quercus macrocarpa from the west. We brought this in, and we've been using it on a city street trees. I help with the master list for trees in the city and the state, and Quercus macrocarpa has been filled in for purposes for its resilience in the city, being able to tolerate the heat and the poor soils. The bur oak is really an amazing tree, and we had it on our campus. Although the acorns are much bigger than our regular red oak species. And I talked about Tsuga canadensis, and they're replacing this one at Longwood with the Chinese Tsuga. And they're finding what they're trying to do is figure out the shape and the form of the plant and how the animals interact with it, but also the type of seed that's critical for certain birds. And if it's close enough to the seed that they're eating now, the likelihood of them being able to eat this seed is very good. And so, and I'm just showing you some old pictures of Tsuga, where it was used as barriers and buffers and hedges back, I want to say back probably in the 90s and 80s, that you don't see anymore. They're all just skeletonized. And of course, woolly adelgin is one of the big problems with it too. So Tsuga canadensis being replaced by Tsuga chinensis. It's not from our country. I know people get really disturbed that, we're not using a native, but the structure and the seed source is very critical for the birds to make sure that they get the same kind of nutrient values from the plants. And so this is what it looks like. It has a shinier foliage, and it has a similar stature, and it has just a little bit larger cone so that the seeds are not too big, and you get an idea of how that functions. So how another big project that happened not too long ago, I think it was 2015, a place called Haddington Woods in the Philadelphia region, in Fairmount Park. They decided they were going to do a project where the canopy was really overgrown with invasives, and it was just in deplorable condition, and it was part of the park. And they said, what are we going to do here? We're going to do a project, and it's going to be an experiment. And this experiment is going to be an important part for animal migration and plants. And they picked this large area, 60 acres, and they redid it. And in the green, you'll see they were looking first at density for the canopy. What kind of density can we create, and see if density actually affects how invasives sneak in, but also food sources, what's going to grow well, and how is that going to function. So they used, like in some areas, in 0 plants. That's the 0 going down diagonally. And then they increased the numbers of 19 to 44 to 89 density of tree canopy of our natives, and discovered that the denser the canopy, the better it is to fight against invasive species. Then they decided in 1, 2, and 3 in the bottom that they were going to bring up, not only plant an upper story of southern species, but they're also going to plant a whole woodland underneath of southern species as well. So they picked the yellowwood, loblolly pine, southern redwood, southern red oak, beautyberry, and also Carolina allspice. Not native to our region, but south enough that maybe when the temperature's warm, that these plants could probably come up with animal movement. And so they had these planted in these different locations, in 3 different locations. And what they discovered was that there was very few of these species that died, and they were all brought up from the south. Wow, that was pretty telling. And there was a lot of animal activity that was taking place there with these new species being brought up. Now, I want to say that the arboreta in our area already had a lot of these other species that were non-native to our region. But the idea of being able to make a forest with them and make a naturalized area that would be or represent our local community forest worked really well. And some of the ones that you see here, Calicarpa, Carolina allspice, yellowwood, all of them functioned really well. So that meant that we could grow them here and start to incorporate them in our understory. And the trees that worked well, we've actually put into our city streetscapes, like yellowwood and Quercus falcata. Pinus taeta, we're still experimenting with. We had good luck with that at Longwood Gardens, and they survived down in this Haddington Wood project. But it depends on the actual siting as to whether it's going to survive or not, because of real cold dips in the temperature. But on a whole, everything really performed well. So that was kind of interesting too. So Cladastris kentuckia, which is the yellowwood, is now being planted at Longwood. And Longwood has their new conservatory. They planted this outside, and it is beautiful. And the foliage, but also the flowers, have attracted a plethora of pollinators. And of course, there's a lot of bird activity too around these. You'll see where it was typically native, and now you'll see where they are growing it in other locations around the country, these pale green sites. There's not a lot of them there, but there's enough of them there to give a population coloring on these USDA charts. And so we also look at Pinus taeta, loblolly pine, really beautiful tree used in the timber industry in the South, really important tree, and a really I think it's just a beautiful, I just love the stature of it and everything. And here you can actually see it. The bark is really beautiful. Again, animals are interacting with the pine cones and the seed, which is critical for animal movement and food sources. And here it is again on top. This no longer exists because of Longwood's new addition, but they planted taeta in other places on the campus. And you'll see that Tata really didn't come up as far as Philadelphia or even the surrounding counties. It was found mainly in New Jersey and Maryland and Delaware. Quercus falcata, we did have southern red oak in our area, but mainly in botanic gardens. And because of the heat, it performs better than the regular red oak in our area, northern red oak. And this was one that we had at Temple Ambler campus, which was enormous. And again, lots of animal activity. And the cones, the acorns are similar to the northern red oak, and a lot of bird activity. So you kind of get the idea that, and you can actually see that over time, it has naturalized in our region, and it's expanding. We're actually expanding southern red oak into our state of Pennsylvania to accommodate any losses in our regular northern red oak. Calicarpa americana, the American beautyberry, is another one that the birds just go crazy over. This picture was taken at the end of the Trail of Tears in Oklahoma, and that was the first time I had ever seen it. And one of my native friends said, you know, this is the end of the Trail of Tears, and this is where we planted all our medicinals. And this one here, he said, people should be planting like crazy because it's a really important bird food for migration. And it's a beautiful plant. So you can actually see that it is being moved up north. Calacanthus floridus, this is another one, Carolina allspice, a beautiful shrub. It spreads. It's a great riparian buffer plant. It's great on hillsides because of its nature to spread and reduce the overall need for mowing and any other kind of disturbance on a hillside. And these are the flowers for it and the foliage. And you can see here that it is already naturalized in the western part of the Pennsylvania and into Maryland. Maryland doesn't have any markings. It's there, but it hasn't had its numbers counted. And you'll see as you go further west and down south, that's where it's typically native to. And of course, up in the upper regions of New York, the botanic gardens have had it for years, so it's naturalized itself. Fafagella major is another one that is a critical one for our region because it is in the Hemimalidaceae family and provides a early spring nectar for pollinators. And here it is. This one here happens to be major, but we have also Gardinii too, which is the dwarf Fafagella. And you notice that it's only found in several counties throughout the country, and we are moving it up so that we have some additional pollinator food. Hydrangea quercifolia, this is another one that's really a great one that we typically do not have in our region, but has really been adopted for understory in our native areas. It does really well, and landscape architects are using it too in the city. It does really well in the city as a plant. Again, food source for small beaked birds, critical for smaller little animals on the ground. And here you see its native region. Again, that heat temperature, as it moves up, you'll see the plants moving further north and disappearing from our regions. Itea virginica, a Virginia sweetspire. This is another one that is one that I've been teaching for quite a while. I teach woody plants, and this one here is the species form, but some of the cultivars are just incredible, and encouraging people to plant the cultivars. Some people say, oh, you know, it's not a native, but if it's going to provide pollinator nectar and food sources for other animals, it's really important that we encourage it. So we have lots of different cultivars, and in this case, most of the native cultivars are naturally formed plants that have been put into production and given a cultivar name. So a lot of times people think, oh, these have been, these have been purposely crossed by people. No, these have been found in the wild and then brought into production and given a cultivar name. So you'll see that in the regions, in certain regions, even in Pennsylvania, have actually naturalized. Leucothea fontanesiana, the fetterbush. This is another one that's really wonderful for riparian areas where you have a lot of erosion, problems with soil, and this one here really holds back hillsides and provides a nectar source for pollinators. And this is in the ericaceous group. So you'll see those little urn flowers, which is so classic for this. Also a really good cut foliage as well. And you notice Pennsylvania doesn't have anything. Maryland has a little bit, but it then jumps to New York. That's because it was used early on for riparian work and also in the botanic gardens. And here's the native area for it. Morella cerifera. I'm not sure if you have. I know that that's a crossover in Maryland. You might have both. You might have cerifera and Morella pennsylvanica. The fruit on the female plants is really important for animals, and most people don't think about that. This is cerifera on Fenway Island down in Delaware. And I just thought, this is just beautiful. It really can be used in a lot of different ways. And the waxy berries. The leaves are a little bit narrower than Pennsylvanica. Not as shiny either. And here you can actually see that where it would typically be found. So why do plants need help migrating? And we talked about this. There's not the animal populations being killed right and left. We actually have to be the animal that's going to help move it. And we don't typically think of ourselves as an animal like all the other animals, but we are part of nature, and we have an obligation. If we destroy something, we better make sure that we fix it. So the historical context of migratory trails is critical. And if we understand the migratory trails, then we can actually help and cure some of these problems. These are all the flyways for the bird populations and insect populations when they're moving. So when you think about that, we take the same roads. We just mimic the animals that we see around us. How things are flying, that's how we move. When we see animals on the ground moving, that's how we move early on. And that's how we created our roads. And I mentioned that earlier. And you'll see that these are the 4 major flyways in the United States. And you think about how we need to support this bird movement and the plant movement. So if we can actually help to increase the numbers of plants that the birds eat, that also helps them to make sure that they have the proper nutrition that they need as they travel, to give them the boost that they need to get to where they need to go, especially on the West Coast, because there's a lot of broken areas. But the West Coast is really the first ones to start to build those land bridges and underpasses for animals. And here's the 101. There's a place called the Liberty Crossing, which has been under construction for a while, and it wasn't in construction long before they started noticing that the animals were already using it, which tells you that they will adapt if we let them and if we build it. So like they say, if you build it, they will come. So the headline on NPR: across the world, migrating animal populations are dwindling. And again, we ask why. And again, our movement and how we do things affects the migration. And nearly half the world's already threatened migratory species are declining in population. So just to kind of give you an idea. And this is and I need to say this because this climate crisis is not political. It is not political at all. It has to do with the animal population responding to how we move and how we operate. That's what is happening here. And as we move and as we heat up certain areas of the world, we're going to see a change in animal movement. So, here again, crawling, flying, even fish are affected. I know here in Pennsylvania, the shad are so critical. And for a long time, we didn't even have a shad festival because there wasn't enough shad in the river to have a festival because of the various things that were going on within the river. Here's the Liberty Bridge, the canyon crossing, and it was built for, I think it was a bobcat. And they started building it, and as I mentioned, the population was disjointed. So as soon as they put the bridge there, that disjointing was matched, and it was able to connect again. So it was really important for mating, the mating season. So you're going to see more and more bridges across our roadways, and as long as our engineers continue to think about animals as well as people animals, that we have these bridges for animals to cross. So these crossings, actually restore the ecosystem, especially when they're all fractured into little million pieces. How do you traverse an area? And in fact, I'm sure you have some areas too in Maryland where they'll close a road in the springtime because the frogs are crossing or the turtles are crossing. We do it here in Philadelphia. We have one major roadway that gets closed every year because thousands of frogs are crossing the roadway. So how can we help? Well, we talked about that. We can, but more importantly, to extend the food sources, making sure that we have plenty of food that we are planting in our gardens. This is where we come in. Whether we're building a rain garden, whether we're building a just a formal garden, just putting things that the animals can eat is really critical for them. Being mindful that the animals carry the seed in their guano. And I always like to point out when I'm out in the wild and I'm even in someone's garden, like yesterday, I said, look, there's American holly growing here. How did it get here? And everybody looks, oh yeah, the bird was up in the tree and it dropped its guano and here's the seed. And if you let people know that and let them see that what's happening in nature, we can actually repair it so much easier by understanding how these things work. And here, humans, we've actually done a lot of irreparable damage, but again, if we can fill in those voids in our own gardens, in our own communities, when you're creating these gardens, it's going to be a huge thing for the animals that fly and walk through our communities. Consider designing hubs, animal stopovers. And I'm sure I love going to Maryland, but I have to say this because Maryland has some of the most beautiful landscapes, especially along their highways, because they have these beautiful median strips that are planted with tons and tons of native plants that are really, as soon as I cross the border, I just know I'm in Maryland because that's how conscious you are on your roadways. And these are the same roadways that the animals are traveling. Build more land bridges, free up airspace and water lanes during migration, and keeping the lights off during migration. This is so critical. I used to have to pick up the dead birds on campus and put them into the freezer before they went down for their autopsies at the Academy of Natural Sciences. But one guy called me the one day and he said, oh my gosh, he said, I'm here at main campus, and he said, I picked up 1,000 dead birds this morning. That's horrible. We shouldn't have that kind of thing happening in our society, especially when we know better. And again, people are working on the West Coast, and some of these people who are propagators. Steve, for example, he produces probably some of the most, actually the numbers he produces are some of the biggest numbers of plants in the world. 15 million seedlings a year he grows. And what he does is he goes from British Columbia and down into Washington and Oregon to pick up seeds so he can purposely prepare their communities for the global warming that's happening. And he said he can't believe the difference once they plug in these southern species into these northern areas, and they could actually see the resilience. But also the cross-pollination of these different phenotypes also helps to create a various phenotypes that will survive in the future. So that's something we need to think about too. And of course, Dave Tuschler, he's no longer at Devil Mountain, but he's working in the same capacity doing growing. He was telling us that on the West Coast, he goes down to Mexico to get his seed and brings it up into LA and the region in that area, because this seed, because of the heat in the southern part of the state. And so he also likes to develop seed nurseries. So think about this as something that you can all do. Create a seed nursery where people can come and glean seed for their production. This is another way to do it. And what he does is he goes to schools and he finds these plants on the school property that are really good seed sources, and he pays the children to pick up the acorns and the other type of seed, and writes them out a check every year when he goes to collect the seed. And of course the school loves it and they're learning. So this is another way we can kind of integrate our learning environment for our children too, so that they're aware of what's going on. And again, local food sources for the animals. And I want to just quickly get through here. Amelanchiers, another good one for Amelanchiers, found all over, from all the way up by the North Pole all the way down into Mexico, but they change height and shape. So lots of different species, but they're doing the same thing. And you can see that that's Amelanchier, but this is blueberry. I wanted to go through this quick because I know I'm running out of time. The blueberry is another one that's, you'll see its importance. And Vaccinium corymbosum, large cranberries, again, another one where you'll see these are for migration. Aronia melanocarpa, another one important. You could see on the eastern coast and also on the major mid flyway. Aronia, another aronia, red aronia, or red chokeberry. Again, take a look at its mapping. When you look at these USDA maps and you see the fruit or the food along this coastline, that means that it is a migratory plant. So if we know that it's a migratory plant, and that's why these maps are so invaluable, you look at these and you say, okay, this is a migratory plant. Let's plant more of it so we have plenty of it for the birds. That's what we should be doing. Here's Itea again. This is a cultivar, but wow, when that's in bloom, you can't even get near it because there's that many pollinators. So kind of give you another one, Cirilla. This one here is native from Virginia all the way down to the tip of Brazil to South America. That's how important this plant is in migration. So you get an idea of the importance of some of these plants. Euonymus americanus, another one that has a strong connection with migration. Zenobia pulverulenta, even though it is found only in a small spot in the United States, we think it's important that we bring it up because it has important pollinator benefits. And of course, clethra is another one. Again, we find it all along our coastlines. I'm sure you all see it in Maryland, in the wetland areas, etc. And Xanthoxylum americana, the toothache tree, another critical plant. and you'll see how important it is to the 3 different flyways. Aeschylus pavia, another one for hummingbirds. This one here, if it's in bloom, the hummingbirds are there. If it's in bloom, every time I see it in bloom here, I will see a hummingbird. The hummingbirds follow that up the coast. And the Euonymus atropurpureus, the eastern wahoo burning bush, another really good one, food source for animals. And you can see its importance there. So when you look at those maps, Prunus maritima, another one, the beach plum. I don't know why we're not planting it along our salty highways. This can tolerate such an incredible range of soils and I want to say salt spray. A great one. And this one here is found in the northern parts of the country, but again, we could be taking it up further north. This is my book that I wrote because I felt it's really important that shrubs are being recognized. Shrubs in particular are critical for migration. That's the berry source for many animals and for their survival. And I appreciate you having me do my talk. I think it's really important that we all know what we need to do to help our animal populations and to correct some of the things that are going on in the environment.
Oh, thank you, Eva. Hey, I know it's 10:05. We have a bit of time here for if you're okay for answering some questions.
Sure.
I'm sure my crew's gonna have some questions for you, so it's really interesting. I just want to say a quick thank you. I think it's very enlightening. I think this is going to start some conversation here. It makes us think of things a little differently. But at this point, I think Sue DeGraba, who's with our tech team, she's been fielding through the questions.
Yeah.
If it's okay. She's kind of represent some of the questions and she kind of consolidates them. She's gonna, field them to you.
Please. I'll be happy
Okay.
to.
Thank you, Sue.
Okay, so the first is actually more of a comment, but you may want to comment. The increase in ticks has been reported to be largely due to fractioning of ecosystems.
Yes. Well, and also, we had a real big problem with Berberis, and Berberis is an invasive. It's Japanese barberry, and for some reason, it's the structure of that in the spines that encourage the development of more ticks. And I've had Lyme disease 3 times. I've had the debilitating side effects from Lyme disease, so I can totally relate to this. And yes, the ticks are an important, they're an important insect for grouse, chickens, birds that typically eat at the ground level. They're not berry eaters. They're insect eaters. So, do we have enough of those birds to be eating, or have we lost so many of them that they're not gleaning those insects? Something to think about.
Thank you. The next question is Fothergilla. I mean, I may be mispronouncing that. Doesn't seem to last too long. I've heard it needs more consistent moisture. Any tips to keep this beautiful shrub going?
Love it, love it, love it. And I love your question. It typically is found along riparian areas, stream banks. So if you're going to plant it, put it in an area where it's going to get morning sun, but late afternoon shade. And it likes those little puddles or those planted around a vernal pool. That would be a great place to put it. Or on a slope or near a gully where you're going to so you don't have to mow. You've got the shrubs there instead. That's a good place to put it. And I think that there's a lot of places that we can enliven with these plants that we're not using enough creative thought when we plant. Hopefully that helps.
Thank you. Another question. We recently planted a red chokeberry. It's got beautiful red berries and leaves. Wondering why it seems like no birds have been eating the berries.
Oh, they don't eat that until much later. And in fact, there's a whole range. So like when you go into your Ilex verticillata, for example, all the different cultivars that we have ripen at different times. And most of our cultivars for my ilex are natural crosses that have occurred on their own, and they put them into production. So each one has its own ripening time. And it's the same thing with Aronia. There are some crosses between the purple berried form and the red berried form, and you'll see them like kind of nondescript kind of colored berry. And you'll say to yourself, how come they haven't been eaten? But they take longer to ripen because they have a thicker covering and shiny surface. So they will last much longer. And there'll be a berry that they typically glean on their way back from the winter. That's usually when they're eaten. Hopefully that helps.
Thank you. That's really helpful. Another comment and question. I'm all in on supporting migrating birds and animals, but hearing you recommend burning bush made my ears perk up in a scared way. How do you balance support with wildlife with avoiding invasive plants?
They're not invasive. They're the natives. They're the native. The Atropurpurea and the Euonymus americanus are natives. They're not burning bush. I'm not advocating burning bush. No. That's Euonymus alatus, which is the burning bush, and I would not recommend that at all. So hopefully that kind of quells your anxiousness around that. So no, they're natives.
Thank you for that clarification.
Yes.
Another question. Warming is global. Why do plants native to other continents manage heat when U.S. equivalents don't?
Well, here's something really fascinating. You know, when we were all one landmass, Pangea, and we started to split apart, the different plants started to create a variation in their visuals that were once all connected and to fit that particular location. And as they continued to move, some places moved into cooler locations while others moved into warmer locations and adapted that way. And in areas where we have less activity, less human activity, especially in Europe, there's a lot of places where there's not as much activity. Those plants can survive without any problem because they don't have the human interaction and the human, all the human other things that go along with it, like cars and other warming agents. That's why they can survive, especially in Europe, because it's a little bit colder. Their mountains are horizontal rather than vertical. So that's another thing that makes a difference in how something will survive or not. And if you take a look at that, just that in itself, it gives us a broader type of plant material versus Europe has less native plant material than we have because their mountains are horizontal versus vertical. So they don't travel as far either. So does that make sense to you? I mean, the idea of the different quadrants and how things move, that makes a huge difference as to how things can survive or not survive.
Thank you. And a comment that someone else came in about the birds go for the red chokeberries late in the season. I've read they taste better after freezing. The birds will be eating insects and other higher fat berries as well as seeds before they get to the chokeberries.
That's exactly right. And the person who wrote that, here's the other thing. Birds are very, very mindful. The first berry that they eat are the dark berries because they're antioxidants and they ripen and they get softer quicker. Then they go after the red berries. Then they go after yellow berries, and then purple berries are somewhere in between there. And then they go after the white berries. White berries are not as delectable and they're not as nutritious. So the birds know that by the visual or whether they're seeing color or they're not, there's something about it that they can tell the difference.
That's very cool. That's all we have in the chat. For all of us, I want to thank you. This has been fascinating. So much information.
Thank you. I really do appreciate it. And I wish you all the very best in your continued success in your work that you all do. It's so important for all of us.
Back to you, Steve.
Okay. Um, Okay, guys. So we've got a little bit of a block of time here. We're going to do a little bit of a bio breaker and that. But before we do that, I need to thank Eva for her presentation. Thank you, Eva, and hope that you guys got a bit out of this. I think this is very interesting. So I'm going to pause it real quick here for a second.
Providing insectaries or homes for mosquitoes to, or sorry, not mosquitoes, beneficial insects to nest and overwinter, and then creating other habitats. But of course, there are also insects that we don't want in our gardens, particularly mosquitoes. So what I'm going to focus on today is what we can do to keep ourselves safe from mosquitoes while we garden. So for a little bit of an outline of what I'm going to cover in this presentation, I'm going to start by briefly giving myself a bit of an introduction, talking about who I am, and sort of a little bit of a brief summary of my journey to becoming a PhD student studying mosquitoes. Then the first half of the presentation is going to be sort of an introduction to mosquitoes in general, where I'm going to talk about mosquito diversity, their life cycle, and then of course the disease risk that they present. And then the second half of the presentation is going to be more specifically focused on mosquitoes and gardening, and the overlap there and what we can do to make sure that we are safe from mosquitoes when we're spending that much time outside in our yards. Okay, to start with who I am. So I went to Vassar College in upstate New York in Poughkeepsie. And there, I declared my major in biology pretty early on and started studying. I joined a lab studying tree frogs, as you can see in that top left picture. I was interested in sort of evolutionary biology in general and animals. Sorry? Yeah, sorry. They were hourglass tree frogs. So I joined a lab studying those. I did a couple of projects on those. I worked with birds, capturing owls for tagging. I worked on an ecological preserve. You can see me being nibbled on by some goats here. And then after I graduated college, I joined Horn Point Lab on the Eastern Shore, part of the University of Maryland Center for Environmental Science. And I learned some genetics and molecular techniques for monitoring river herring in the tributaries of the Chesapeake Bay. And after working there for 2 years, I joined Megan Fritz's lab at the University of Maryland, where now I do research on Culex pipiens mosquitoes, which are the main species that transmit West Nile virus in the United States. And like Steve briefly mentioned in my intro, I'm interested in how urbanization and sort of landscape modification influence the risk of West Nile virus transmission in how it creates, destroys, modifies habitats that these mosquitoes and the other hosts involved in the West Nile virus transmission cycle use. So I also have a couple pictures here of me at conferences. I also really enjoy doing outreach. Here I am in a preschool class talking about insects. And then this is at Maryland Day, talking about mosquitoes and the life cycle of mosquitoes. And then the top right picture is me in the field with one of my undergraduate technicians collecting mosquitoes, which we do every summer. And then at the bottom right, I'm giving a presentation to the entomology department. So I'll jump into the first half of the main sort of body of my talk, which is just a general introduction to mosquitoes. And hopefully I teach everybody here something new. I'm going to try to fill this with a lot of little interesting fun facts. I've got some videos in here too. So maybe like me, you will learn to appreciate mosquitoes a little bit more before we start to jump into the more obviously negative parts of mosquitoes. So first of all, what is a mosquito? So mosquitoes are, of course, insects, and they're in the order Diptera, which are the flies. And there are about 150,000 species of flies, including house flies, horse flies, hoverflies, crane flies, and then, of course, mosquitoes. And mosquitoes belong to the family Culicidae, and there are two of their unique features that help us recognize mosquitoes when we see them are their proboscis, which of course is what they use to take blood meals from hosts. And then actually they have these very fine scales on the margins of their wings, which when I'm sitting at a microscope and sorting through a bunch of insects from one of my traps, when I see this, I can be pretty sure that I'm looking at a mosquito. So mosquitoes are actually incredibly diverse. There's more than 3,500 species of mosquitoes known across the world. And as we can see in this top left picture, they can range in size quite a lot. They can range in shape, color, behavior, and a whole host of other characteristics. So a lot of people, because they're so small and because they're so annoying, a lot of people figure that there's probably only one type of mosquito or a couple types of mosquito, but they're actually a very, very diverse group of animals. And I'm going to go into a little bit more of that diversity as we keep going. And so despite all of the bad press that mosquitoes justifiably get, actually only a very small minority of species bite humans. So just 6% of species of mosquitoes bite humans. The rest, the other 94%, bite other animals to get their blood meals, including birds, other primates, even frogs and snakes. And then a really strange case is that Uranitania saporina, which is this mosquito with these really cool shiny blue streaks of scales on their bodies. They actually blood feed on worms. And I've actually caught a few of these in my traps before, and they're really cool to see under the microscope because of those bright blue scales. Um, and so an important fact about mosquito hosts is that some mosquitoes are very specific to certain hosts. So Uranitania saporina probably only feeds on worms, whereas other mosquitoes are more flexible and can bite a variety of hosts. And in some cases, it's those more flexible species that can bite different types of animals. Those are the species that may pose the greater disease risk because they can pass pathogens from humans to animals, which in the case of West Nile virus is what happens between birds and people. There is one type of mosquito that doesn't blood feed at all, and this is the elephant mosquito, which is in the genus Toxyrhynchites, and it's also the largest species of mosquito. So in that picture where I was showing the comparison between the two mosquitoes of very different sizes, this was the large one. So it doesn't blood feed at all. Both males and females only feed on plant nectar as adults. So it's a weird case of a mosquito that actually evolved away from blood feeding. And I'll talk a little bit more about how that works later on. So mosquitoes also live in a huge variety of different habitats and environments. So from salt marshes to forests to cities, and different species have evolved different adaptations to each of these environments. Mosquitoes are also extremely geographically diverse as well. So this is a map of the distribution of different Anopheles mosquitoes, which is the genus that spreads malaria. And as we can see, there are dozens of different species of Anopheles spread all across the world, different species living in different continents, different groups of species living in different continents. And I guess one of the part of the subtext of this image is that there are mosquitoes in the United States that are capable of spreading malaria. And in fact, until just after World War II, malaria was actually very, very deadly in the United States as well, before we were able to sort of eradicate it from our country. But as you may know, all mosquitoes need standing water to breed, as 3 of the 4 life stages in the mosquito life cycle require water. And so that's going to bring us to talking about the mosquito life cycle. So mosquitoes have 4 life stages. They are a holometabolous insect, which means they go through complete metamorphosis. And so these 4 stages are egg, larva, pupa, and adult. And I'm going to sort of go over each one quickly and hopefully have a fun little video for each one as well. So we'll start by talking about eggs. And this will be our first introduction to what I sort of call the big 3 genera, or that's the plural of genus. So the big 3 genera of mosquitoes: Anopheles, Aedes, and Culex. And so the reason that these are the big 3 is that the majority of all mosquito species fall into one of these 3 groups, and so do the vast majority of mosquitoes of public health importance. So for that reason, these are the 3 most well-studied groups. There are a number of other types of mosquitoes aside from these 3 main groups that I'll sort of talk about in a little bit, but these are really the big 3. So to start talking about eggs, a mosquito's life begins as an egg, typically laid on the surface of the water. And in the case of Anopheles on the left, these eggs are laid individually, and they have these tiny little floats on them to keep them from sinking. So they actually float on the top of the water. And you can see in that picture that they sort of end up forming these little triangles with each other. Moving towards the middle, Aedes eggs are also laid singly. And in some species, they're actually laid just above the surface of the water on the edge of a wall or a container, where they wait for up to months at a time before the water rises due to rainfall, and then the eggs can hatch. And this is a unique feature of some Aedes mosquitoes, that they can lay their eggs outside of the water and they can sit there drying out, not being wet, and still be viable to hatch when they get wet again. And so this is how a lot of invasive species were able to cross oceans, where the eggs would dry out on the edges of containers, at the edges of water barrels, and then come across ships, oftentimes in used tires, and then come over here, get wet, and then hatch, and then now we have a new species of Aedes mosquitoes on our continent. Culex eggs, the last one to the right, are interesting because they're laid in these contiguous rafts that float on the surface of the water, and they cannot survive being dried out like Aedes eggs. So now we're going to watch a short video of Culex eggs hatching, so we can see a little bit of a transition into the larval stage. And hopefully nobody is freaked out by this video, but if you suspect you might be, I guess I would look away. But we're just going to see a couple of little mosquito larvae hatching out of an egg raft. Hopefully this plays. Are you guys seeing this, or you saw that?
Yep, we got it
Okay.
back.
Cool. Okay. I just checked and it was looking like it was showing my face. Okay, so that was a view from beneath the surface of the water. We could see little first instar Culex mosquitoes hatching out of their egg raft. So that brings us to the larval stage. So of course, the larvae of each genus are different as well. Anopheles larvae are unique. They rest lying parallel to the surface of the water, and they breathe through a very small rudimentary breathing tube. And the reason that Anopheles are unique in a number of ways is that they diverged from, or Anopheles mosquitoes are in a separate group of mosquitoes from Aedes and Culex mosquitoes. And those two groups actually diverged from each other 7 or 8 million years ago, which is as long ago as humans and chimpanzees diverged from our common ancestor. So Anopheles mosquitoes are sort of a completely different creature from a number of other types of mosquitoes, sort of just reinforcing the idea that there's quite a lot of diversity in mosquitoes. It's very cool. And then Aedes and Culex, on the other hand, rest at an angle at the water's surface using a long tube called a siphon to breathe. And so mosquitoes go through 3 molts as larvae, passing through 4 stages or instars as they grow and prepare to pupate. So I'm going to show another little clip of a video of some Culex larvae, and we'll see how they breathe and eat underwater. So we can see them hanging from the water's surface by their siphons and moving their little mouth parts to filter feed. So they're moving their mouth parts, creating a current in the water, and they're sucking through any sort of organic debris, bacteria, and they're feeding on those. And so here we can see that their siphon actually has these 5 little flaps that keeps the water sort of tension away, and they can pull air in through that, and that's how they breathe. Really close-up view of this. This is a pretty incredible video. And then depending on how much food is available, how much competition there is, and other important factors like temperature, mosquitoes can pass through all of their larval instars in anywhere from 4 days to 2 weeks. And here we're seeing an Anopheles larva too, sitting parallel to the surface of the water. It does this thing where it can rotate its head 180 degrees, which is pretty wild. Kind of like an owl, I suppose. And then, yeah, here we can see it filter feeding, bringing through these little algae particles that it's chomping on. And nobody probably agrees with me, but the amount of time that I spend with mosquito larvae, I start to think they're kind of cute. They're little nibbling. Oh, so the elephant mosquito that I mentioned earlier, the largest species of mosquito, the only species of mosquito that does not blood feed as adults, the reason why it doesn't need to blood feed as an adult is because it is actually a really fierce predator as larva. So this giant larva we can see right here is an elephant mosquito larva. And what it does is it feeds on other smaller mosquito larvae. So we'll see this elephant mosquito larva hunt down and eat one of these Culex larvae. And so it's actually a species of mosquito that may be an effective biocontrol for other species of mosquito, which is kind of interesting. So once the mosquitoes have eaten enough food and molted 3 times, they become a pupa. So this is equivalent to the chrysalis or the cocoon stage in a butterfly or a moth. So we'll have a short video here. Watch this fourth instar larva molt into a pupa. And you can see that it has these two little horns, two little trumpet-shaped horns on the top of their head. That's what they now use to breathe. And unlike many other insect pupal stages, mosquito pupae can move, and pretty quickly, to avoid danger. And it is during this time that the tissues in the mosquito's body are being rearranged and reconstructed into its adult form. But look at how they sort of tumble around. They're called tumblers sometimes. And now we've reached the adult stage. So once the mosquito has finished pupating, which typically takes between 24 and 48 hours, it's ready to emerge as a flying adult. So let's watch this adult mosquito emerge from its pupal casing. You can see the back of the case cracks open and air starts to enter, and then the adults will slowly ease themselves out and onto the surface of the water. It's a little bit creepy, especially the way that it's shown in this video. We'll see it from the surface. They sort of just like slowly emerge as like these totems from the water, and then pop their legs out. This is sped up. When it happens in real life, it takes a little bit of time, and you can see them slowly emerging out. But now they have to sit on the surface of the water for a little bit and wait for their new exoskeletons to dry and harden before they can fly away. So this is actually maybe the most vulnerable point. And you can see it excreting some water there as it dries out. So once an adult mosquito has emerged, males and females have quite different tasks once they're adults. Of course, both need to find food, which is usually in the form of sugars and plant nectar. So a common misconception about mosquitoes is that they only drink blood. But in reality, most of the time, mosquitoes' energy comes from feeding on sugars like plant nectar. And males only feed on sugars and plant nectar. It's only the females that ever take blood. So once an adult has found food, it needs to find a member of the opposite sex to mate. And from this front view, we can see the difference between male and female mosquitoes. And the biggest difference we can tell is the bushiness of the antennae, where males on the right here have these very bushy antennae, which amongst other things, they actually use to listen for the sound of females' wings. It's that high-pitched whirring sound, humming whirring sound that we associate with mosquitoes. And the way that mosquitoes mate is that the males and females actually locate each other in these big breeding swarms by listening, in the male's case, using those antennae for the exact pitch of the wing beat hum of the female that they're interested in. And what's really cool is that males and females will actually speed up or slow down their wing beat frequencies to match or even harmonize with each other before mating. So that's sort of their mating ritual. They listen for each other's wing beats. They try to find a wing beat frequency that they like.
Hey, Ben, are you there? Uh, I think I lost Ben. Sue, are you there?
Do we have a phone number for him?
Yeah, I do. So yeah, let me check in with him, see something happened. I'm just trying to check our staff, if it's just me or is it everybody? Okay, I'll come,
Yeah,
I'll reach out. I'll reach out. Put on mute here too.
And maybe pause the recording for now.
Where was the last? What was the last thing you guys saw?
Oh, I'm trying to remember, Ben. I think you.
It was the antennae matching.
Yeah.
Yeah.
The
That's
two
right.
mosquito faces with antennas.
Okay, cool. Yeah, so I'll go through this quickly in case you hear it twice, but the male mosquitoes use those bushy antennae to locate females by listening for a specific hum beat or wing beat frequency that they like. And they're able to find each other in these breeding swarms by listening for a specific frequency of wing beat. And they're able to match each other and harmonize, and that's how they find each other in midair. And I actually think that's kind of beautiful. A lot of people, are quite anti-mosquito for obvious reasons, but they have some cool behaviors that sometimes go underappreciated. So they find each other in these mating swarms by listening for specific wing beat frequencies that they like. They have this intricate sort of dance in midair where they're, approaching each other and touching each other in certain ways before they finally make genital contact and can copulate in midair. Okay, here we go. So Sabathes, which we saw earlier in my mosquito diversity slide, is a bright blue and sort of feather-legged mosquito, and it has a really intricate mating ritual, kind of like some birds of paradise. So I'll show you this short clip of that, which is very cool. So here's the female. She's resting on this surface. A male approaches and then is trying to initiate mating with her. He's doing this little leg waving thing. And if that impresses her, she'll lower her abdomen like this. And then he's able to attempt copulation by bringing his abdomen closer. But once they touch, there's not actually any exchange yet. And he has to do another little dance for her with his legs. He does this, this sort of the wave, which is very cool. And then once she's ready, he is able to complete the process, and soon she's gonna kick him off once she's done with him. She kicks him right off. And so this guy, this is the guy who studied that. He says, of course I study mosquito sex. Why wouldn't I? But that just kind of goes to show that despite mosquitoes being, vectors of disease, there are still some really interesting behaviors, like many other animals in the animal kingdom. So once a female mosquito has mated, the next thing she needs to do is take her blood meal. So she needs the blood to be able to get the proteins that she needs to develop eggs. And so mosquitoes have a number of important body parts and use many different cues to locate a host. So first thing they're looking for is carbon dioxide, which we are constantly breathing out and which can travel far distances. And so using sensors on their antennae and on their maxillary pouch, mosquitoes locate a plume of carbon dioxide being exhaled by a human or by another animal, and they start to trace it back in the direction it's coming from by first turning upwind and then by casting or zigzagging back and forth. And so if during this casting they see an object as they track the CO2 plume, they will approach it and they'll search for heat and moisture and host-specific smells. If they don't sense any of these cues, like if they're just approaching a tree that happens to be in the direction of the CO2 plume, they'll continue down the plume of CO2. Then once they do encounter a host, they use close range cues like heat, moisture, and then specific volatile compounds and specific smells, like the smell of the sweat on our skin, other smells coming off our skins, and that will tell them, first of all, that they've located the type of host that they want to bite. So mosquitoes are very, very specifically tuned to the odors of the specific host that they've evolved to bite. So in the case of mosquitoes that bite people, they're very specifically tuned to pick up on the smells of our skin and our breath and so forth. And then, of course, they will land on our skin and they'll start to taste and probe around with the tip of their proboscis, the labellum, before they finally bite us. And so when mosquitoes bite, they quickly excrete saliva into our bodies that prevents our blood from clotting and prevents us from feeling any immediate pain. And that way they can fill up their abdomens very quickly with blood without being noticed and fly away. However, that injection of saliva has a number of consequences. The first is that soon after the mosquito leaves, most of us have a little minor allergic reaction to many of the compounds in the saliva, which is what causes the swelling and the itching that usually comes with a mosquito bite. And second is that if a mosquito happens to be infected with a virus or other pathogen, the pathogen is then passed into our bloodstream when they inject that saliva. And so this is how mosquitoes end up transmitting disease, is that one step where they inject saliva into us to make sure we don't feel their bite and to make sure our blood doesn't clot before they can slurp it up. So when a mosquito takes a blood meal, they can ingest as much as 2 to 3 times their body weight in blood, which is the equivalent of a human drinking an entire bathtub's worth of liquid in only a few seconds. And so to accommodate this, mosquito abdomens have a really stretchy membrane in between the top and bottom hard plates of their abdomen, which allows the whole abdomen to swell to a very large size as they ingest blood. And if you can notice during this video, mosquitoes will concentrate actively. They'll actively concentrate the blood as they drink it and excrete excess water at the back of their abdomens as they drink so that they can concentrate the blood. They don't have to take up quite as much liquid. And then, of course, it is also in the process of taking this blood meal that a mosquito can acquire an infection of a pathogen if the host they bite is infected. So for a mosquito to spread a pathogen from one host to another, it needs to take 2 blood meals, which happens frequently. So once a mother mosquito has the blood she needs, she has to find a quiet resting spot where she won't be disturbed and where she can digest the blood meal and develop her eggs. And it's during this period that any pathogen that a mosquito acquired may infect her body and spread into the salivary glands, where she would then be able to disseminate it at her next blood meal. So this period of time is also very important for sort of epidemiology of mosquito-borne disease and transmission. So finally, we complete the life cycle with the mosquito the female mosquito finding a suitable source of standing water to lay her eggs. And there is a vast diversity of locations that females from different species prefer to lay their eggs. So for example, in the top middle here, this mosquito species is called Wyomia smithii, which is the pitcher plant mosquito. And so they only lay their eggs in the water in pitcher plants. So it can be as specific as that, or it can be much broader. Some species can lay their eggs in salt marshes, and they're specifically adapted as larvae to deal with the slightly saltier water. Others in puddles, and then many forest mosquitoes lay their eggs in tree holes at the bottom right here. So these little holes that appear in tree trunks that collect rainwater are really good sources for many species of mosquitoes to lay their eggs. However, the mosquitoes that most often cause problems for people are adapted to lay their eggs in small man-made containers like tires and flower pots, clogged gutters, bird baths, and even volumes of water as small as a thimble. And we'll get back to that in a little bit when we talk about venting mosquitoes in your backyard. So general mosquito biology, ecology, and behavior is definitely cool, but we all know that the main reason that most people care about mosquitoes is the risk that they present to human health by being vectors of many different dangerous diseases. So in Maryland, there are about 60 species of mosquitoes, both native and introduced. In the genus Aedes, there are 2 invasive species, Aedes albopictus, the tiger mosquito that we're probably all familiar with, and Aedes aegypti, which is the yellow fever mosquito. Both of these are present in Maryland, although Aedes aegypti is pretty rare for now, as it is a more tropical species that is adapted to warmer temperatures. And so you can tell these 2 species apart by looking at the markings on their backs. Aedes albopictus has a single line, whereas Aedes aegypti has what is called a lyre-shaped pattern. And I was actually just at the grocery store and I saw an Aedes aegypti just resting on one of the flower bouquets that they were selling. So they are here and they are quite a lot more common in urban areas because urban areas stay warmer for them. There are also many native Aedes species in Maryland, many of which are tree hole and forest spring species that we can see down here. The genus Anopheles, there are 2 main species in Maryland, Anopheles Punctopenis and Anopheles quadrimaculatus. And so these are the species, the genus Anopheles is the genus that is the vector of malaria. And like I mentioned earlier, malaria has been eradicated in the United States, but if the malaria parasite was reintroduced into the United States, these species would be able to vector it. So that's obviously something we need to continue monitoring. The genus Culex, Culex pipiens and Culex quinquefasciatus are both introduced species, and they're both here. And there are also a number of native Culex species like Culex restruens and Culex salinarius. And again, this is the genus that I study, that the Fritz lab studies, and this is the genus that spreads West Nile virus. And finally, there are a number of interesting and rare species present as well, including those from the genus Saurophora on the top there, the elephant mosquito, Toxyrhynchides, which I mentioned earlier, and then a small group of mosquitoes called Culiceta mosquitoes. But there are three main species of concern in Maryland. So Aedes albopictus and Aedes aegypti are both very effective vectors of a number of viruses, including dengue, yellow fever, chikungunya, and Zika viruses. And so these diseases for now are mostly limited to tropical and subtropical regions, Central and South America, Southeast Asia, Africa. But there have been a number of isolated outbreaks of these diseases in Florida, Hawaii, Texas, and Puerto Rico in recent years. And Culex pipiens is the third species of concern, which, as I mentioned, vectors the most prevalent mosquito-borne disease in the United States, West Nile virus. West Nile virus was introduced to the United States originally in 1999. And since then, there have been thousands of reported cases and unfortunately hundreds of deaths per year. So this is why many labs around the country, including our lab, is very interested in studying this mosquito and trying to understand its biology, its ecology, and its epidemiology the best we can so that we can learn the best ways to prevent it from causing so much disease. Culex pipiens is also a vector of other viruses like St. Louis encephalitis, Eastern equine encephalitis, avian malaria, and some filarial worms. It can be the species that may give your dog heartworm, as does Aedes albopictus, as we can see on the left. But of course, we're most concerned with West Nile virus. So to make matters worse, global climate change is pushing more and more subtropical and tropical mosquitoes further north into more temperate regions like the United States. So what we're looking at here is some predictions of how the suitable range of Aedes aegypti, the yellow fever mosquito, may shift in the coming decades as the climate continues to warm. So in general, mosquitoes adapted for the warmer temperatures of the tropics will find it easier and easier to survive and thrive in the United States. So this concern is central to much of my research and much mosquito research in general. So on that slightly foreboding note, I'm going to shift into the second half of the talk, where we're going to talk about mosquitoes and gardening. So as someone who studies mosquitoes, one of the most common questions I get is, what are mosquitoes even good for? What do they contribute to the ecosystem? Can't we just kill them all? You wouldn't believe how many times I hear that every time I do any sort of outreach. And while the answer to that is pretty complicated for a number of reasons, sometimes I do get to surprise people by telling them that mosquitoes are pollinators, and therefore they do contribute to the ecosystem. So like I mentioned earlier, males exclusively feed on plant nectar, while females also often feed on nectar when they aren't looking for blood to develop their eggs. And because of that, mosquitoes inadvertently end up pollinating many different species of plants. And while mosquitoes aren't necessarily vital for the pollination of most plants, there are some species, particularly those that live in marshier, wetter areas, that do depend on mosquitoes for pollination. So as an example here, the snow pool mosquito, which is called that because it breeds in the pools of recently melted snow, is an important pollinator of orchids in northern regions of the US, particularly this species we can see here, the blunt leaf orchid. And so this species has small flowers, and they're a great source of energy for these mosquitoes. And when the mosquito flies in to drink some nectar, a little bit of pollen often gets stuck to the mosquito's eye, which it then brings to the next flower it visits. Despite this, you probably don't want mosquitoes in your garden, and there are plenty of other less annoying, less dangerous pollinators that you would rather attract. So let's move on to how you can keep your garden as mosquito-free as possible. So before preparing for this talk, I hadn't actually spent much time thinking about the intersection between gardening and mosquitoes. So the first thing I did was start researching what people online were saying. And it turns out that a lot of people claim that there are certain plants that you can put in your garden that will produce odors that repel mosquitoes. So we can see how many YouTube videos there are covering this topic, all of these uploaded within the last year or so. I dug a little bit deeper, however, and it turns out that this is mostly not true. While there are several plants whose oils are somewhat repellent to mosquitoes, like citronella grass, citrosa, and eucalyptus, these oils are only produced when the plant's leaves are crushed and ground up. So you could crush up the leaves and rub some oil on your skin, but the plant just sitting there in a pot or sitting there in the ground does not actively keep the mosquitoes away. And some of the studies I read about this were saying that the mosquitoes were just landing right on these plants, hanging out, resting, digesting their blood meals, whatever. The plant is not actively producing the smells and the compounds that scare the mosquitoes away. It's the oils inside the leaves that need to be crushed up for that to work. So what will keep mosquitoes away from you while you garden is actually pretty simple. It's just bug spray. So there are a couple of types of effective insect repellents that will do a great job of keeping mosquitoes away from you. And by far the most common in the US is DEET-based repellent, which I'm sure most of us are pretty familiar with. So as a demonstration of how effective DEET is, I'm going to show you this video of a researcher sticking his hand into a cage of Aedes aegypti mosquitoes, first without DEET and then after rubbing DEET on his skin. So this again might be a little bit of a gross out video. But I'm going to speed it up because he holds his hand in there for a little bit. But so this very first video, he has no DEET on his hand. This is just his control hand sticking into this cage. And we can see just how many mosquitoes instantly swarm to his hand and start biting him. And I'm surprised that he has the patience to let this happen. But I've heard from other mosquito researchers that the more you do this, the easier it gets. You start to react less and less. So I haven't tried it, but it's actually kind of common among mosquito researchers. So now we'll watch, if I have the right video here. Yep, so now we can see his hand with DEET on it. That's the T means test. He put DEET on his hand, and now we can watch him stick his hand in there, and almost no mosquitoes land on his hand. This one lands, walks around for a little bit, and then gives up. So we can see just how effective DEET is at keeping mosquitoes away. So we went from his hand being absolutely covered in hungry mosquitoes to no bites at all, almost like his hand was invisible. And in fact, that is what happened, at least from the mosquito's perspective. Despite being called a repellent, DEET is actually more accurately described as something like an invisibility cloak, like in Harry Potter. And this works because, like we talked about earlier, mosquitoes are able to locate you, to bite you, by smelling the unique odors that emanate from your skin. And DEET works by trapping those odors against your skin and preventing the mosquitoes from being able to smell them. And so you can buy DEET-based bug sprays with various concentrations of DEET, even up to 100%. But it is perfectly effective anywhere from 10 to 35%. But if you want it to last longer, you can go up to 50%. Past that, you run the risk of some skin irritation and some oiliness, though for the most part, DEET is pretty safe. There are two other effective mosquito repellents recommended by experts. The first is similar to DEET in that it also acts as an invisibility cloak and is a synthetic chemical, and that's called picaridin. And in practice, it's not very different from DEET, but it can be used at lower concentrations, and it's less oily and irritating, making it the more popular choice in some parts of the world, particularly Europe and Australia. If you prefer a more natural choice, the oil of the Australian lemon eucalyptus tree is the best choice, which, the oil of lemon eucalyptus, excuse me, is essentially just as effective as DEET and picaridin, but the only drawback is that it breaks down faster on the skin and does not last quite as long. So it should be reapplied every 2 hours or so, whereas DEET and picaridin probably don't need to be reapplied after more than 6 to 10 hours. What's interesting too about the oil of lemon eucalyptus is that the exact reason why this oil keeps mosquitoes away is not yet well understood. But again, there are studies that show that it is clearly just about as effective as DEET and picaridin while being a natural extract. So a lot of people prefer that than the synthetic chemicals. Despite the synthetic chemicals being safe, if you prefer a natural solution, then oil of lemon eucalyptus should be your go-to. Another extremely important part of keeping your garden and the area around your home in general free of mosquitoes is making sure that there are absolutely no sources of standing water that the mosquitoes can breed in. Each of the 3 species of concern that we discussed before, Aedes albopictus, Aedes aegypti, and Culex pipiens, are specialists at breeding in small man-made containers like flower pots, discarded trash, bird baths, tires, and clogged rain gutters. So you need to store your flower pots upside down, dump everything out after it rains, and particularly make sure your gutters are clean. And you will find way fewer mosquitoes in your yard. You should also tell your neighbors to do the same because, of course, once the mosquitoes are mature adults, they can fly into whatever yard they please. So if you're doing the best job that you can, making sure that there are no breeding sites in your yard, if your neighbor close by has a lot of mosquito breeding sites in their yard, you're going to get their mosquitoes just as bad. Mosquitoes won't lay their eggs in moving water. So installing a small fountain, if you have a bird bath or a small pond, will be effective at preventing mosquitoes from breeding there. Ponds too, if you add certain species of fish, like mosquito fish, guppies will eat mosquito eggs and larvae. But if you do have a small pond or a small bird bath where you would like to keep some standing water, there is a solution. You could put mosquito dunks in any standing water you do want to keep. So products like mosquito dunks or mosquito bits are formulated to slowly release a larvicidal bacteria into the water over the course of about 30 days as they dissolve. So this bacteria, Bacillus thuringiensis israelensis, also known as BTI, is found naturally in the soil and does not have any effects on non-target organisms. That's one of its greatest strengths. It's very effective at killing the larvae of mosquitoes, fungus gnats, and black flies, but it does not kill almost anything else. It's not harmful to any other wildlife. It's not harmful to people. It's not harmful to pets. It's a pretty powerful solution. So I'm not sure if the sound
Let's make a
for
mosquito
this is
bucket.
going to play.
Actually,
It has captions anyway, so we'll just watch it. Basically, this is one strategy for keeping mosquitoes away from your yard, is that you basically give them a place to breed. So you fill up this bucket with water and organic material that will be attractive to the mosquitoes laying eggs, and then you put a mosquito dunk in it. So the females will come, they will lay their eggs, but then unfortunately to them, I guess fortunately for us, all of those larvae will pretty soon die after they hatch. And so what you're doing is you're bringing mosquitoes from around your yard that would otherwise be laying eggs elsewhere nearby, and you're basically bringing them to a trap where you're going to help reduce the population. And so this larvicidal bacteria, BTI, works by producing these toxic crystal proteins when the mosquito larvae ingest the bacteria via their filter feeding that we saw earlier. And so these crystal proteins bind to specific receptors in the lining of the mosquito larva's gut. And what that does is that it then opens holes, it opens pores in the gut, which of course causes death pretty quickly. And it's the specificity of these crystal proteins, their specific match with receptors in the mosquito's gut, that ensures that this does not harm other insects or other animals. So this specific strain happens to match the gut lining of mosquitoes, fungus gnats, and black flies, but it won't hurt other organisms. There are strains of BT, Bacillus thuringiensis, that are targeted to other insects. My lab, the Fritz lab, also studies corn that has been genetically modified to express BT proteins that will kill the corn earworm, which is a species of caterpillar/moth that is a pest to corn crops. So across sort of insect control in general, this is a very powerful strategy for a biological control agent. So in conclusion, protect yourself with one of these 3 types of insect repellent and make it very hard for mosquitoes to breed in your yard, and you should be able to garden in peace. And with that, I would like to thank you very much for your time and attention, and thank you for bearing with me as my internet connection dropped out there. And I would be very happy to answer any questions that you might have.
Thanks, Ben. I think we got Tina on
Yes.
board. Hey, Tina. Why
Okay.
don't you go ahead?
Okay. I'm going to start you at the end. We got a flurry of questions. So,
Great.
how many times does a single mosquito lay eggs?
That's a very good question. So essentially, it's as many times as they are able to take a blood meal and survive long enough to digest that blood meal and find a place to lay their eggs. So I think that I have read studies that the majority of mosquitoes are only able to lay one set of eggs, if any. But there are mosquitoes that get lucky enough to survive long enough to be able to take a blood meal, lay eggs, take another blood meal, lay eggs, take another blood meal, lay eggs. And it's those mosquitoes that survive the longest that are the ones that present the biggest disease risk, because if they're taking multiple blood meals, they have the opportunity to acquire an infection and then pass it to something else. So I think most mosquitoes are only able to lay one set of eggs, but some get up to 3, 4, 5. And there are some mosquitoes that live 3 or 4 weeks. So it just depends on if they're lucky, they don't get eaten, they don't get squished, stuff like that.
Okay. What time of year do mosquitoes breed, and when should we put out any kind of like our mosquito trap with the dunk?
Yeah, so that becomes a pretty complicated question because there are so many different species of mosquitoes that survive in such different habitats. Generally, around here, mosquitoes can start to sort of emerge, particularly in the suburbs, as early as the end of March or beginning of April. In some areas in the city, where it's really urban, and there's all of these underground locations like sewers and subway tunnels, stuff like that. Mosquitoes can be active year round because they can shelter from the winter in those underground areas and come out when they find somebody to bite. But yeah, in general, they respond to temperature. So depending if it's a warmer summer, the mosquitoes will come out earlier. If it's a cooler summer, they might come out a little bit later. But I would probably start using mosquito dunks, as early as the spring. As soon as, you want to start being outside, I would put them out.
And I'm assuming the first frost, heavy frost, does them in.
Yes, most of the time, yeah, they will be sort of in their state of sort of hibernation by that point.
Okay. Can the BTI survive in the soil and kill gnats and other larvae?
Oh, that's a good question. I'm not actually sure about that. I know that it is found naturally in the soil, but I know that this specific strain of BT, the BTI, that I is for Israelensis. So this specific strain was actually found in Israel. I'm not sure if it is found naturally in the soil here or not. But that's a good question. I'm actually not sure.
Okay. And how far away from, say, a mosquito trap do you bring the mosquitoes in? What's their range?
Yeah, that's another good question. That also depends on the species because different species have very different flight ranges. For Culex, which I'm the most familiar with, I know that when I set my traps to collect them throughout the summer, they could be coming from as far as a kilometer away. They fly very far distances. Aedes aegypti and Aedes albopictus, the two, black stripy-legged mosquitoes that are of concern, they actually don't move quite as far. They have a much shorter range. But certainly for the extent of sort of like a typical yard, they would be coming from that area and some of the surrounding areas too.
Okay. Can you comment on the potential risk of a yard spray like Mosquito Joe?
Yeah, so the risk of sort of traditional pesticides like that, which I'm assuming is what Mosquito Joe is that you are going to reduce the population of adult mosquitoes in your yard for sure, but you're also killing every other insect that lives in your yard. So traditional pesticides have many what we call off-target effects. So they're killing the mosquitoes, but they're not specific to mosquitoes. They'll kill basically everything else. And that's not to say that like traditional pesticides and spraying for mosquitoes should be stopped because when a Department of Health or a mosquito control agency identifies a mosquito that's infected with a disease like West Nile virus, the best thing to do is to spray and try to get rid of all of the adult mosquitoes in that area to make sure that we don't have a disease outbreak. But in general, we are trying to move away from using, those broad spectrum pesticides that are going to reduce biodiversity of insects across the board.
Okay. Can you comment a little on fans and using fans to keep mosquitoes away?
Yeah, I mean, mosquitoes are not strong flyers. So if you're just sitting out on your porch and you can set up a fan to be blowing across you, you probably aren't going to have mosquitoes landing on you. What I notice is that they often fly towards my feet and my ankles, and I get a lot of bites down there at my feet and my ankles. So you would probably also want to have the fan blowing down there. But yeah, mosquitoes are not able to fight against a fan blowing for sure.
Okay. Are you familiar with mosquito torpedo? Does it harm amphibians? Active ingredient is methoprene, S-methoprene.
I don't know. I've not heard of mosquito torpedoes. So I actually don't know if I can comment on that. I'm looking it up right now, but
Okay. Okay.
it does look like off a very initial Google that it is targeted towards insects. It's not mosquito specific as far as I'm reading right now. But it doesn't look like it harms non-insects, so.
Okay. But it would be indiscriminate about the type of insect it would.
Correct, yeah.
Okay. I have a couple here. What predators of mosquitoes can we try to attract to our yards?
A really interesting one is dragonflies. So for adult mosquitoes, dragonflies are actually really effective hunters. There's a really cool statistic that in terms of like hunting animals, and this includes like sharks, wolves, lions, dragonflies have the highest success rate for hunting. They're really, really maneuverable and fly around and can eat other flying insects out of the air really, really targeted and effectively. So adult dragonflies are actually a really good way to take care of adult mosquitoes as sort of like a natural ecological biological control. And then in their aquatic stages, things like mosquito fish, guppies, those will eat the larvae and the eggs and the pupae of mosquitoes as well.
Okay. Which stages of the mosquito can survive out of the water and for how long? I think you went through that, but if
Yeah, I mean, certain species, like I mentioned, the certain Aedes species, their eggs can survive out of the water for quite a long time. Certain other species go into diapause, which I didn't get into the talk, but diapause is like insect hibernation. And certain species diapause as eggs and diapause as larvae. So for the most part, the egg, larva, and pupa needs water, but there are some cases where there are certain species that have adaptations to survive out of the water for, periods of time.
okay. I'm gonna do a little bit of history. What were the principal strategies in the US to eradicate malaria?
That is a great question. So right after World War II, the United States and the CDC was formed principally to eradicate malaria in the United States. And so basically the main way that they did that was that the Army Corps of Engineers and many other agencies and local agencies across the US did a huge amount of work in draining tons of swamps, draining lots of areas with standing water by digging ditches, draining that water, destroying ecosystems, unfortunately, and spraying a lot of DDT, spraying a ton of broad spectrum pesticide. And so, both of those practices we would probably disagree with today, as DDT was really, really toxic to the environment, killed lots of organisms, was a big problem for biodiversity. And then draining swamps, that's also habitat destruction. But the result was that we don't really have malaria in the United States anymore. So that's sort of the trade-off that we went with. Yeah.
Okay. Okay, I have a question that's come up a couple times. Why do mosquitoes love to bite some of us and ignore others of us?
Yeah, so that's another one of the questions that I very frequently get when I do outreach. And so there is a common misconception that it has to do with your blood type. Um, but most of the research that I have found and that people that I've talked to have mentioned does not show any evidence that blood type has much to do with it because um, a mosquito is not going to know what your blood tastes like until they've already bitten you. Um, so it has to do with smell. So some people just have certain odorants that come off of their skin. It has to do with sort of like the microbiome on your skin. It has to do with how much you sweat. It has to do with the smell of your sweat. It has to do with how heavily you breathe, so breathing out that carbon dioxide. And some people say that it has to do with what you eat and then how that translates into sort of the odorants coming off of your skin. So really the main answer there is that it's the smell of your skin, and certain people have smells that just end up being more attractive to mosquitoes than others.
Okay. And then if you could talk a little bit about these pots of water with dunks, like how close they would need to be, how often you would switch them out, how effective
Yeah,
they really
so
are.
You probably only need one per yard because, like I sort of talked about earlier, the mosquitoes will come from pretty far away to lay their eggs in that stinky smelling water. If you make it, stinky and attractive enough for them, they'll come from pretty far away. So you probably don't need more than one unless you have, quite a large yard. So I would say probably, you shouldn't put them any closer than half a kilometer apart from each other, like 500 meters. Um, and the dunks themselves are supposed to last 30 days. So yeah, it will just fully dissolve into the water after about 30 days, and then you might want to replace it after that.
Okay. Do birds eat mosquitoes? You mentioned dragonflies and fish.
Yeah, I do think that birds probably do eat mosquitoes, but I don't think that they're generally considered a very sort of effective control for mosquitoes because I think in general birds I'm no bird expert, but I think in general the insectivorous birds prefer larger insects. Mosquitoes are pretty small and don't have a lot of, meat on them, so to speak. So they certainly will eat mosquitoes, but I don't think that they would be they wouldn't have a very significant impact on a mosquito population.
And I'm seeing someone says that bats eat quite a few.
Bats will also definitely eat mosquitoes. The difference there is that, of course, bats are nocturnal, so bats will be eating the mosquitoes that are out at night. But many of the mosquitoes, like Aedes aegypti and Aedes albopictus, um, those will be mosquitoes that are active during the day. So the bats might not be necessarily as effective for controlling those species.
Okay. And in what form do they survive that winter, during the winter? You had mentioned that a little.
Yeah, so the species that I study, Culex pipiens, survives the winter as an adult. So the females, if once the days start to get shorter and the temperatures start to cool down, it triggers diapause. So what they'll start to do is they're almost like bears. They'll start to eat a lot of sugar, try to build up some fat in their bodies, and then they'll find a place, often sort of like a cellar or a storm drain, where they sit there, they sort of like almost go into hibernation where they, reduce their metabolism. They sit there and they wait out the winter. And if they are able to find a place that's sheltered from the cold, they'll survive the winter there, and then they'll come back out when it warms up again and, go for a blood meal and try to bring the population back up. Other species survive as larvae and can survive sort of under the surface of like a frozen pond. And some species survive the winter as eggs, and then the temperature and the light again will trigger them to hatch again and come back out.
Okay. And my understanding is the dunk trap piece really is pulling down on the population, not
Yeah,
stopping biting.
correct. Yeah,
Okay. I think that is all of our questions.
great.
Hey,
Thank you
Ben.
very much.
Thank you
Hey,
so much. It
hey,
was
Ben. I
my
was going to
pleasure.
follow. I got one or two questions myself. On a larger scale, they talk about reducing the mosquito presence by releasing sterile mosquitoes. How your thoughts on that, or how's that
Yeah,
working?
so the sort of the main way that people have been talking about doing that is by using another type of bacteria that naturally infects insects called Wolbachia. And Wolbachia is like a parasite for many, many, many species of insects. And it has this very strange method of working where males can pass Wolbachia infections to females in mating and cause that female's offspring to then be infertile. So a lot of times when there's a particularly bad outbreak of a mosquito-borne disease, um, mosquito control agencies can release infected males into that population, and that will crash the adult mosquito population pretty well. There are also talks about releasing genetically modified mosquitoes in certain parts of the world. I don't think that's been done yet because of the sort of ethical challenges with that and the potential risk of other ecosystem-wide sort of impacts. But Wolbachia infection is an effective technique for that.
Interesting. Hey, I got one more for you, Ben. As far as like these traps, these for mosquito traps that release CO2 or anything like that, or other kinds of things, or these bug traps or things like that, sometimes you see. Any of your thoughts about those?
Yeah. So there are a couple of different ways to like trap mosquitoes for monitoring. What I do is I use what's called a gravid trap, and because that's very targeted towards Culex mosquitoes, which is the type that we study. And so what gravid traps do is it's just a black plastic bin, and we pour really stinky water into it. So like we fill up a big bucket of water, put alfalfa hay in it, and then just leave it for a week or two, and it gets really stinky and organic. And we pour that into this black plastic bin, put a fan on top of that bin, and leave it overnight. And so Culex mosquitoes coming to lay their eggs in that water will fly down towards the water, and then a fan sucks them up into a net, and that's how we trap them. Maryland Department of Agriculture uses what are called CDC light traps. And so those do use CO2 to attract mosquitoes. There's a similar setup where you have a little fan, usually hanging from a tree with a light at the bottom, and then something on the top. Sometimes it's like a little jug with a spout that has dry ice in it, and that will release CO2. That will attract all types of mosquitoes, not just Culex, all types of mosquitoes and other insects from far and wide. And then because insects are attracted to light, once they get close enough, they'll fly towards that light and then they get sucked up into a net too. So it's those CO2 light traps that are used for sort of like broad monitoring of all mosquito species, whereas I use gravid traps because I'm particularly interested in trapping Culex mosquitoes.
Okay. So nobody uses those like for commercial applications. This is more for research, these traps.
Yeah, because setting a trap like that, you're not necessarily doing much to reduce the mosquito population. Whereas if you're sort of setting up this bait of a bucket and it has the mosquito dunk in it, you're bringing in mosquitoes that would otherwise be laying their eggs elsewhere nearby, and you're bringing them into a place where they're going to lay their eggs, and those eggs won't be viable because the larvae will hatch and then get killed by the mosquito dunk.
Okay. Tina, did you have a follow-up or?
Only that I have a number of comments, spectacular presentation, wonderful videos. Everyone was very appreciative of the videos and thinking
Glad to hear that.
not yucky at all. So there.
That's great. That's
I'm
great.
glad. Yeah, I like to keep it hopefully a little interesting with some videos and fun facts and stuff.
Mm-hmm.
Okay, so hey guys, we're still a little bit on the early side of things, and I appreciate Ben for all your time and hanging in here with us. And so again, we'll take a little break here. Before we go, I want to thank Ben for his presentation. Thank you very much, Ben. And so we're all right, everybody. Thank you for hopefully you're coming back from your break and joining us here for our next presenter, our final presenter, three presenters here for today. But before I forget, one other thing is that our next meeting, monthly meeting, is going to be in person. It's going to be at the fairgrounds, November 6th. Andy Lazur is going to be there, and he's going to speak to us on a topic. I think it's important topic. And the title of the talk is "A Challenging Issue Presented I'm sorry. Yeah, contaminants in our soil amendments, a challenging issue. So it is. And so I don't want to give it away anymore. That's still Andy's thunder, but I hope you can join us in person and we will record that presentation as well. So this afternoon, I'm pleased to present to you Dr. Karen Burghart, who's going to be speaking to us. And I was going to read you a little bit about Dr. Burghart's bio. And then it goes, Dr. Burghart has been working with municipalities and states about ramping up their tree planting efforts to expand canopy cover and provide ecosystem services such as shade, biodiversity support, and stormwater management. Achieving these goals requires not just planting trees, but ensuring they survive and thrive in harsh urban environments. Because of the heat and pavement, oh, I'm sorry. I'm reading the presentation here. I'm sorry, Dr. Burke. Let me get my notes here. I'm reading your presentation, your bio. I'm sorry. Dr. Burghart is an associate professor and extension specialist in the entomology department at the University of Maryland College Park and a research associate at the Smithsonian Environmental Research Center. Trained as a community ecologist, she specializes in understanding plant-insect interactions in human-modified landscapes ranging from city streets and urban yards to abandoned agricultural fields and managed forests. By examining how management practices impact the support of the biodiversity in these spaces, the lab's research program helps determine the best practice for how humans can coexist with a variety of flora and fauna. Karen received her master's and her doctorate in ecology from evolutionary biology from Yale University, where she studied herbivore-induced defenses in goldenrod plants. Before that, she received her bachelor's from the University of Delaware, where she studied the role of native plants in ecosystems. So at this point, I'm happy to let Karen get started with her presentation.
Okay, thanks for that, Stephen. I am going to be, everybody can see my screen? Everybody can hear me?
Yes.
Sounds good. Okay, awesome. So I'm going to be talking today about selecting trees for resilience and landscape biodiversity. I have this kind of tripartite appointment where I have a research extension and teaching appointment. And hopefully you'll see how all of these things kind of fit together through my presentation. I looked at our presentations for the day and noticed that the first speaker was going to be talking about climate resilient species. And so I am going to talk about selecting trees for resilience and landscape biodiversity, but I'm also going to throw in a decent amount of integrated pest management and insect biodiversity data into this talk. So hopefully you will enjoy it. All right. So, my slides are not advancing. Let's see if I can. Do this again.
I think you got it there for a second.
Well, so I can do it in this format. It's just not as full screen.
I mean, that'll work, but I thought you had it for a second there, but maybe.
As here? Did it actually?
Yeah, it looks good right there.
Yeah,
Full
but I
screen.
can't advance the slides.
Oh no.
Like I'm hitting a forward button and it is not actually like going to the next slide.
So it's not a different share. Okay, understood. Okay.
Yeah. Let me see. All right, let me try one thing. Okay, that's working now.
Got it.
Okay, perfect. All right. So what our lab spends its time thinking about is how differences in human management and our choices in landscapes change plant-insect interactions in those landscapes. So we've done work in a lot of different habitats. Today, I'll be primarily talking about some of our urban work on street trees and work in suburbs and in managed forests. So we're kind of going to cover a decent number of habitats, but the goal of all of these is to understand how our manipulations, how our changes in habitat that we as humans like to do affects many of the other creatures that inhabit those spaces with us. And the extension piece of this tends to overlap with the goals of integrated pest management. So integrated pest management, which I know that you all have covered kind of in your basic trainings, is a science-based approach that combines a variety of control tactics to manage pests. And the goal here with integrated pest management is you aren't actually decreasing the populations of all of these pests in the landscape. You're trying to create an ecosystem that is going to control those pests to begin with so you don't have these problems. And so our lab's role in this is to try to understand, okay, how can we build habitats as humans so that we don't actually need to do a lot of chemical controls and other aspects of pest management that can have negative ecological consequences. And so the start of this often comes in spring when you have a nice kind of landscape that's just starting to bloom out. You have a lot of different species perhaps in your yard. These are pictures from my yard. And then you'll get something like an outbreak of aphids. So this is a trumpet honeysuckle. If you all have this planted in your yard, around here, there is a non-native aphid, the Tartarian aphid, that pops up in very early spring, often in large numbers on the flowers. And so your first instinct might be that this is a very bad thing, and I need to treat this in some way to decrease this population on my plants. And my kind of goal for this talk is to potentially convince you by the end that you might actually need more insects kind of in these spaces year round in a steady kind of population in order to actually prevent outbreaks of the most problematic pests in these landscapes. And so if we can select species and create landscapes that support a healthy and functioning food web, then we're going to be able to prevent more of these pest outbreaks. So the goal of this is to sort of think through what are evidence-based strategies for designing a pest-resistant landscape, but one that's also going to be resilient to climate stress and biodiverse. And the key thing here is these pest-resistant landscapes aren't necessarily going to be insect-free. Instead, you have to actually support a diverse set of critters on that landscape. And so maybe by the end, I'll kind of get you to the point that maybe it's okay that we have these aphids that are starting out as large populations in the early spring in some of our landscapes. So the integrated pest management strategy that my lab focuses on, and I'm going to be talking about for this talk, are really cultural practices. So these are practices about how we grow our plants, how we arrange our landscapes, so that they are less likely to be attractive to some of these pest species. So what I'm going to be talking about today is, choosing the right tree in the right place as a cultural practice. If you have healthy trees and happy trees, they're less likely to be negatively impacted by pests. We'll talk a bit about diversification and how we can promote conservation biological control. So many of these cultural practices also do a good job of increasing our predator and parasitoid populations that help control pests once they do potentially come into a landscape. So the talk I'm going to be giving is kind of broken into a couple sections. This first section is really thinking about what insects are doing in landscapes and defining some terms that I'm going to be in inside integrated pest management. This will probably be review for many of you, but it'll help create context for the rest of the talk, which is going to be about 4 different strategies that you can use to create these resilient and insect-friendly landscapes. So I think insects are one of these very interesting groups because they play a dual role in ecosystems and for humans. They're a really important part of food webs. You all have probably heard about how important they are for migratory birds as this conduit for plant energy that moves up the food chain. They play a really important role in feeding our breeding birds, not just the migratory birds, but the breeding birds that feed their young, these insects, and also larger mammals like grizzly bears, foxes, all kinds of creatures actually have insects as a major part of their diet. Not as often thought about, but I think really important in suburban landscapes is that these guys are also doing a lot of other things to maintain ecosystem services in our habitats. So they're helping maintain these populations of predators and parasitoids to help control potential pest outbreaks. They pollinate, they increase soil fertility, both through their carcasses, but also by helping break down detritus and other matter. And they can increase soil carbon sequestration and actually aerate the soil. So if you think about how cicadas form tunnels, for example, in the soil underneath trees, we have good evidence that those emergence holes are actually helping our stormwater management mitigation and helping aerate the soil and in the spring. So insects are doing a lot for us, but they also sometimes are economic pests or pests in the sense of being disease vectors. So you just heard a talk on mosquitoes, and these mosquitoes are going to generally have more negative consequences on humans. So one of the questions I get a lot is that, well, but if I see an insect in my yard or on a tree, then that means they're a pest because they're feeding on something. And I think it's important to kind of define what pest means effectively. And really, a pest is any living organism that is causing economic or aesthetic damage to a crop or landscape. But this whole concept is based on what is harming us as humans, right? So this means that this is context dependent. So pests, a species is not necessarily always a pest. It's only a pest in certain areas and times when we as humans are feeling harm from this particular insect. So I think it's key to remember that being a pest isn't a species trait because even pests that are really damaging, like think of emerald ash borer, for example, even those pests are not at our pests here in the US, but back in their native range, they're part of the functioning ecosystem. And so it's really important to think of all of these insects as potential important players in the ecosystem while occasionally being pests. And so most of the insects you encounter kind of on your property or in plantings that you do are going to be plant feeding insects, but only a small fraction of them, 0.1% of the species you run across, have ever actually been defined as a pest to humans. So I would encourage you to think about all of the other insects that you see out in the world that are feeding on plants as playing two other potential roles in the ecosystem. So they're potentially feeding food webs and acting as alternative prey items for predators. So these are species that are kind of helping maintain your predator and parasitoid populations. And they're also potentially being competitors for these pest species. So the fact that you have these other species kind of feeding on your tree means that you're perhaps less likely to have a pest species show up. And one of the key things here is that how you build your landscape is going to affect how many alternative prey you have versus pests, the ratio of these two different roles in your ecosystem. And these alternative prey items are going to be really important for helping maintain your natural enemy populations. So we call natural enemies any of the predators or parasitoids that are going to feed on insect pests. And so these can include a lot of different groups of insects, but also things like birds, mammals, rodents feed on a lot of insects, lots of different species. In this picture, you actually have a lot of different potential natural enemies. So these are aphids, oleander aphids. So this is what a normal aphid looks like on milkweed. You guys, if you've planted milkweed, you probably have seen these guys before. They're a non-native aphid species, but many of them are kind of brown here, and you can see there's like a little hole in this abdomen. So this is what we call aphid mummies, and these have all been parasitized by a Burghart wasp that laid an egg inside of it, and actually out of each of these aphids that's brown, a wasp came out rather than an aphid. So we have large populations of these guys in our area. And if you see an aphid population that's showing signs of parasitization, we often recommend not treating it. You're going to do more harm than good because you're actually going to decrease your population of natural enemies that are helping control that pest population. We also have here a syrphid hoverfly or a flower fly larvae. These guys you'll often also find if you have a lot of aphids on your plants, and they will feast on them as larvae. And then the merge as adults, and these are actually flies that are important pollinators, syrphids, in our ecosystem. So having these aphids can help support both predators and pollinators. So why do we end up with potential ratios of pests and parasitoids that aren't kind of optimal? Well, one of the reasons is because pests and predators have different life histories. And so pests tend to have these really fast species that tend to be pests in landscapes, tend to have fast growth rates, these short generation times, and they're only timed to one part of the year. And predators, on the other hand, have these slower growth rates and longer generations. They live multiple years often, and they need to have prey all year long. And so one of the potential problems we have is that if the predator populations are starting at 0 every year, they're not going to be able to keep up with the exponential growth of a pest. They're just not going to be able to keep that pest under control because they can't reproduce fast enough. The goal that I'm going to be talking about today is really to create continuous and diverse food webs so that you are able to have predator populations year round. So if you end up with lots of different kind of herbivore alternative prey species across the year, then you can kind of maintain these levels of predators and parasitoids on the landscape so that they're ready to keep those pests under control. And so in this particular case that I was telling you about before with my trumpet honeysuckle that gets hit by this non-native aphid, what I also find is that by late May, they are covered in lady beetle larvae that are feasting on these aphids. I also have Burghart wasps that are coming out of the aphids. And eventually these lady beetles get this pest outbreak under control, and then they spread out across the landscape to lots of other flowering plants. And so it seems to actually be helping the overall control on the landscape, even if for a little while there's some honeydew and some unsightly things on the trumpet flowers. So that's just kind of an introduction to some of the integrated pest management terms that I'm going to be talking about. And so what I'm going to do now is talk through a few different strategies that our lab has been researching for how you kind of build these food webs in a variety of different managed habitats. So the first piece here, when you're building landscapes that are going to be resilient and produce these biodiversity ecosystem services, are to use site appropriate native trees. And site appropriate is what I'm going to be talking about mostly today. But just so we have our terms kind of in order, when I'm talking about native plants, I know you all do this all as part of your training, but I'm really talking about plants and trees that have a historical, ecological, and evolutionary relationship with the species of insects and other species in the ecosystem that live in this region. So introduced species don't have this historical relationship. So an example here would be autumn olive, which was introduced to the eastern US, but is from Europe and Asia, as compared to black cherry, which is is a native species that's found throughout the eastern US. And again, I want to emphasize that being a native plant is also not an attribute of a species, because this is also context specific, kind of like pests. So a species is native somewhere. It's not non-native everywhere. It has a place that it has evolved with the communities. And so I think that's an important thing to keep in mind. The last piece is you'll run across nativars as a term sometimes. And these are just cultivated varieties of a native plant. There are various ways that you can get traits to stay true in plants, and that is all that's referring to. So the site that I'm going to be talking about today is one of the more challenging places to grow plants in cities. So these are going to be street trees. So we've been doing some work in Baltimore, looking at which native tree species are doing well in some of our most challenging kind of urban conditions. And this is important from an integrated pest management perspective, because there are lots of things about very urbanized landscapes that make them really predisposed to attacks by pests and disease. Trees tend to be stressed in these conditions. They're going to interact with things like telephone wires. They are going to potentially have higher rates of impervious surface. They might have dogs pee on them all the time. These are some of the most stressful conditions that trees can experience. And so our lab has been trying to understand what strategies we can use to better select species for these conditions. So one of my master student who finished up a few years ago went in to try to understand what the different challenges were across an urban management gradient for trees. And basically, she went and sampled insects and tree health traits for 70 red maple and 70 Norway maple trees, all the way from rural forests to urban forest patches to park and residential yard and street trees. And one thing that becomes very clear is that it is much hotter for these trees that are living in streets, near streets, and in street tree pits, compared to trees in parks and residential neighborhoods. And so this is about 96 degrees on average is what these street trees were experiencing. And these were not even the hottest days, because we don't sample trees when it is over 100 degrees, which it often is in August these days. So these street trees are experiencing the hottest temperatures. We also found that they were much worse at lowering their leaf surface temperatures compared to park and residential trees. So basically at the surface of the leaf, if a tree has access to water, it is evapotranspirating and it's going to be cooler at that leaf surface. And what we found is that these street trees are just not able to lower their temperature, and so they are likely not doing a lot of evapotranspiration. And we think this is linked to limited water availability in these kind of small root area street tree pit situations. So this is likely leading to higher stress for these trees. We also found that these trees are hosting many fewer potential predator species like spiders. So the street trees have almost zero spiders that were sampled during EVA's vacuum sampling. So they're also potentially not having as much biological control. We don't really know why this is. Probably it's a combination of it being harder to get to these trees that are sort of isolated in the middle of cities. But also it kind of makes sense that there might be not as many things to eat year round and not as much overwintering habitat for a lot of these predator species. So our approaches to IPM have to be kind of unique for street trees because they are hot, they lack predators, they're often planted in monocultures. And so the paradox here is that her research is showing that we're getting fewer kinds of insects, so different species, different alternative prey items, but we're actually getting more severe pest outbreaks on the trees that are showing. Showing outbreak signs like scale or mites or borers. And I think that one of the things that is exciting here from an integrated pest management perspective is that there's lots of opportunities for tweaks that we can do when we are planting these habitats to create more successful plantings. So for example, maybe you have more species complexity here. And so what we wanted to explore next was one potential practice that we could use, which is species selection. So can we figure out which species are going to do better in these really challenging urban conditions, and then we will have healthier trees that are less likely to be stressed and then be susceptible to potential negative consequences from pests. And there is a lack of data on how species do in these conditions, but particularly there's a lack of data for native species. So native species are going to be an important part of this because they are much better at supporting our native herbivores, alternative prey items. And there's a lot of work that our lab has done on this in the past. And I have their presentations up focused on why native plants in particular are better at supporting food webs. But the question then becomes, okay, you want to plant a native plant or a native tree in these settings, but how do we determine which ones are going to do well, which ones are going to be effective at producing these food webs because they're going to survive? And this became even more important because of things like the 5 Million Trees for Maryland initiative, which I'm sure that you all are familiar with. This is a goal to plant 5 million more trees in Maryland in the next 10 years by the end of 2031. And 500,000 of those are targeted to be planted in urban areas specifically. And as part of this, those trees have to be native. So we now have legislation that's sort of saying that we need to be planting these native trees, but we don't actually know which ones are going to do well in these urban habitats. And so that was what our lab set out to try to figure out. Basically, can we predict which native species are going to do best as street trees? And the way that we approach this is to see if we could use the U.S. Forest Service Climate Change Tree Atlas as a predictive tool for predicting which species are going to do well. So what this Climate Change Tree Atlas does is it models the effects of climate change by species and region. So it's assigning a climate resilience rating to each tree species for a particular city. And the goal here is to see whether these predictions are actually going to help us understand which ones are going to deal with very stressful urban conditions. And so the questions that we were asking here was whether, these trees do seem to care about high neighborhood temperatures and stress. Are these native species doing more poorly in more urbanized areas? And then can we use these predictions to predict which species are going to do well? And so this was part of an urban tree resilience study that was headed up by Maggie Schaefer, who's a current master's student in my lab. And this is her work, and I will put you in touch with her if you have questions. But this study was basically designed to look at 21 native species of tree growing across Baltimore, and look at ones that varied in climate prediction ratings, as I mentioned before. And these are all individual trees that were documented in the 2018 Baltimore tree inventory. They were all small at that point, so they were less than 5 inches in dBH. And what this means is that they had been planted relatively recently, within like the last 5 years or so. They were also in good condition in 2018. So that's important here. So basically every tree we're looking at had made it through kind of the first stress of being transplanted, and then they were in good condition in 2018. And these are all going to be street trees. So these are going to be either planted in pits or along kind of tree lawns that are right next to the road. We selected these trees to be growing in neighborhoods with varying air temperatures and urban stress. So basically neighborhoods were rated based on their average mean air temperature when there was a car drive-by sampling that happened in August 2018. So we can get a gradient of temperatures across these neighborhoods. So what we did was we went out and we took a ton of tree health measurements on these trees. I am not going to be talking about all of these measurements today. What I'm going to focus on is crown vigor and some insect species. But basically, crown vigor is going to be our overall metric of how healthy this tree is. And we used an approach from Healthy Trees, Healthy Cities, which basically combines how much fine twig dieback there is, leaf discoloration, leaf defoliation, branch dieback, in order to get an overall tree health assessment. So what this ultimately means is that you get a rating from healthy to severely unhealthy. And healthy is going to look like this tree, where there's not much discoloration, the crown is intact, all the way to this poor little pin oak that we sampled, which is in the severely unhealthy category. And I think the following year was pretty much dead. So I would say that most of the trees in the severely unhealthy and probably moderately unhealthy category are probably likely to eventually die. We sampled 21 different native species of trees, and I'll go into these in a little bit more detail. But basically, it's about 700 trees that were sampled across the 2 years. So how are these trees doing? after we went and sampled them. Some of them were in rough shape. Somehow we managed to come across a tree that had literally been hit by a car probably the day before. So we can't get data on those trees. But in general, actually, the trees are doing pretty well. So we visited over 700 trees, and 5 to 6 years after they were all in good condition, in 2018, we see that 82% of them are remaining alive. So about 20% of them are lost for various reasons that we don't really totally know. But of those that remain, 75% of those are still in the highest category, condition category, healthy. So again, I think what this is telling us is that urban situations are very stressful for these trees. They die for lots of reasons, not just pests. But we can kind of use this gradient of health to understand more about whether there's differential success of these species across the city. So the first question we had was about whether temperature was affecting crown health. And so you're going to see some figures like this. And basically, this is the probability of a tree being in a particular crown health category. So in basically how you read this is in cool neighborhoods. Most of the trees are going to be in the healthiest category still. So 88% of the trees are still healthy. In contrast, and you have 8% of the trees that are in this kind of slightly unhealthy category. As the temperature gets warmer, basically the trees get less healthy. So in neighborhoods with warmer temperatures, we only have 64% of the trees that are still having healthy crowns. And our percent that are slightly unhealthy have increased to 23%. So basically, when these neighborhoods have higher temperatures and probably also other associated urban stressors, like higher impermeable surface, we see less healthy trees, even when we're controlling for species across the city. And so from an integrated pest management perspective, we were also interested in the insects. And if you guys have been around Montgomery County this year, you will know that spotted lanternfly has shown up in high numbers. And I would say in 2024 in Baltimore, we had major outbreaks of mites and of spotted lanternfly. So the spotted lanternfly were widespread across the city. We had egg masses, we had adults. They were just kind of popping up everywhere. And so Maggie also wanted to know whether spotted lanternfly was responding to temperature. And we think this is an interesting insect to think about in this context because they were first found in Baltimore in like 2020, 2021. So they basically are non-native. They're a nuisance pest. They're not killing these trees. But they feed on a ton of different species and they can kind of tell us about what insects are using to select potential hosts. And we did a visual rating on how many of these were on each of these trees. So this is just a map of where we found spotted lanternfly. And they were feeding on every single one of the 21 native tree species we sampled. But there were clear preferences present. River birch in particular was a major favorite of them. But I think importantly, none of these trees had spotted lanternfly at levels where control would be warranted. So they aren't at such high levels that we would expect to need control. But interestingly, they did prefer trees in warmer neighborhoods. So when we have warmer neighborhoods, our likelihood of a tree having no spotted lanternfly decreases. So they do seem to be kind of preferentially selecting these trees in hotter neighborhoods. Okay, so it does look like these higher temperatures and stress matter for street tree health and probably integrated pest management of pests in these habitats. So our second question was whether we can predict which species are going to do well in these habitats. Whether we can use climate resilience predictions in particular. And there's two resilience predictions that we were using for this study. The first is adaptability, which is a species level attribute, which tries to quantify through expert and literature review how adaptable that species is going to be to a variety of disturbances, like insects and pollution, but then also things like harvest and dispersal, which aren't as relevant to urban trees. The second way that this USDA Climate Change Atlas categorizes these species is by their capability to cope with climate change. And this combines the adaptability score with some modeling data on the abundance of these species and the suitable habitat change predictions under different climate scenarios. And this is basically a rating from very poor to very good for each particular species in each particular city. And so we were basically using the predictions from the greater Baltimore region, which actually also includes Montgomery County, or parts of Montgomery County. So for example, in our 2024 sampling that we did, we had a range of different predictions for both adaptability from low to high, and for these capability scores from very poor to very good. So I just want to say that at the outset that adaptability score alone didn't predict urban stress tolerance at all. So I'm not going to show any more data on that. But that single adaptability score that is at the species level just wasn't very predictive. But these species climate capability scores do seem to predict how well these species are doing in cities. So this is a similar plot to what I've been showing you before, where this is the probability of a certain of being healthy. And basically, if you are predicted to be able to cope well with climate change, then the chance of your tree crown being healthy is substantially higher than if you have a fair or poor rating. So your likelihood of being healthy decreases 35%. So this was results from our first sample in 2024. Maggie's been working very hard to do this for the 2025 data. We can break down that graph into individual tree species. And so, for example, this is what the individual tree graphs would look like. And so you have species that are predicted to do very well under climate change, or very capable, and those tend to do fairly well across all of our different neighborhood types, although there's some variation between species. Our species that were predicted to do quite poorly, like dogwood and pin oak, they did seem to overall do more poorly as mean crown health and mean crown vigor. And then we have some species that the climate models are predicting will be moving into new habitat, and I would say those prove to be variable in how they're doing on the landscape. So, Maggie sampled a number more species in 2025, sampled 500 more trees. And so we have a much wider range of different species that we have data on. And I'm going to show you her results. She worked hard to kind of get these together for this talk. But I'm not gonna, it's gonna be a little bit overwhelming because there's a lot of different species that we're looking at. But the main take home from this is that the new data we have, when we combine it with the 2024 data, it confirms that this capability score is doing a good job of predicting the performance of species on average. So we can probably use this score as a shortcut to predicting which species are going to do well in these really stressed habitats. And I tried to summarize this into something that's a little easier to utilize than all of those kind of figures. And so basically, this is a list of these urban resilient native species 5 to 12 years post planting. And basically, there are species that we find that are doing well across all temperature and stress environments. So things like sweet gum, tilia, it's basically doing well across many neighborhood types. And then there are some species that are going to be doing really well in cool neighborhoods, but still do well in hot neighborhoods. There are a few native species that you probably want to avoid planting in these very hot neighborhoods, um, including things that were a little bit surprising to me, like silver maple, hackberry, and willow oak. Um, but in general, most of them are doing pretty well. I would say that the street trees doing the worst out there as a native tree species, unfortunately, are the flowering dogwoods. This might make sense. I mean, they're an understory shade species, and you can just see that they have pretty low health across all of these different types of neighborhoods. So that might be something to avoid. So what we're finding in summary is that, these really stressful environments are having negative impacts on these native tree species. And we can see that insect pests are also responding to these higher temperatures and potentially causing more problems on these trees. But that capability scores are potentially a good shortcut method for us that we can use to create more targeted diversification and efficient plantings across these urban habitats. And if you are working in more of a suburban environment where neighborhoods are cooler, there's greater canopy cover in general, I think the main take home from this is that virtually all of these native species are performing well in those types of environments. So you can really incorporate these natives into your planting, being confident that in general they're going to do well, and also support a lot of these alternate prey items and build functional food webs for you. So that's just a little bit of a vignette on some work we've been doing for figuring out whether these native species are doing well in urban stressed areas. I will say that a talking point that I get from a lot of the folks that I work with is that these species just aren't doing well in really stressed urban habitats. And I think that this is showing that they are able to do quite well in some really challenging conditions. So other strategies that we can use to create these more biodiverse ecosystems are to use a variety of different species in your plantings. So I'm talking about how to select the right tree for the right space, but we also want to make sure we're not just selecting one species and then plant that over and over again. And the important part there of a variety of species is some risk mitigation. So our lab has been working for the past 10 years or so in a large scale tree diversity experiment down at the Smithsonian Environmental Research Center. So this is just south of Annapolis in Edgewater, Maryland. And these were old ag fields that were planted into a tree diversity experiment where trees were planted in either 1, 4, or 12 species plots. And this was headed up by John Parker, who's a PI at the Smithsonian Environmental Research Center, but has been a huge team effort, as you can imagine, over the years. These plots were planted in 2013 with about 18,000 individual whips of 16 different native tree species. So all of the kind of species in the experiment are native, and they're native to the forests right around there. They're species that you will be familiar with and also are often planted in suburbs and cities. Things like white oak, sweet gum, sycamore, tulip poplar, black gum, maple. And so this is now what an aerial shot of the experiment is looking like. Each of these is a plot. It contains 244 individual trees, and they've been growing for a number of years now. So we can use this experiment to kind of ask about, what does using a diverse planting do for us, if we're thinking about planting in a city or in our own yard, or some of these different contexts. I like to think about each of these plots as maybe like an individual suburban plot. And so what we have found thus far is that diversity doesn't necessarily increase your overall survival of individual trees. So on the x-axis here, we have our monoculture plots, ones that have 4 species or ones that have 12. And you can see that on average, we're getting a survival of about 85% of the trees. But what you see is that individual plots have much more variable survival when they only have a single species in them. So if, say, your yard is all a single species, then you're putting all your eggs in one basket, and it could be that you lose 75% of your trees in that situation. Whereas in these diverse plots, there's a much smaller coefficient of variation. We like to think about this as a portfolio effect. So basically, if you plant all the same species, you're taking a stock strategy, versus if you are planting a variety of species, you have more of a mutual fund strategy. So you get stabilized survival. And we also wanted to ask about whether this has effects on our herbivores, our alternative prey items. And so we did that using caterpillars, which are some of my favorite insects around. These are important because they're leaf-feeding larvae. They come from 2 different orders of insects. So Lepidoptera are the moths and butterflies, and then Hymenoptera, Symphyta, which are these herbivorous wasps, but act very similar to moth and butterfly larvae in the landscape and are host specific to particular trees. So these guys are very important for feeding breeding birds, for doing a lot of that movement of nutrients through the food web. And so we've been going out and repeatedly visiting about 540 trees in this experiment. We've been doing this since 2016. We did our last sample in 2024. So we've been repeatedly doing this, and we do visual search for caterpillars over 4 minutes. And the trees have gotten big over this period of time. So this was in, I believe, 2023. So the trees went from kind of small trees in the middle of fields to what I would now say is a much more forested habitat. So at this point, we've collected over 4,500 caterpillars from 23 families. And just across the 15 species of trees that we've been sampling, we have about 215 species of caterpillars. And our major question was, okay, does it matter whether these trees are growing in a single species plot or a plot that has 12 different species growing in it? And what we find is that it does matter consistently. So when you have the same species of tree, but it's growing in a diverse plot, you have anywhere from about 18% to 113% greater numbers of caterpillars on that single tree. So you're getting greater usage of this tree by different caterpillars. And you get more different species that are using these trees. And so that is more alternative prey items and a more diverse habitat for our predators to use. And sure enough, this was work done by one of the undergrads in the lab, where she looked at spider populations. And we see that spider populations are higher in plots that have more different tree species in them. So we're seeing this kind of support of biological control in more diverse settings. So in general, when you have these diverse neighborhoods, you get more caterpillars, you get more spider predators. We also saw during the cicada emergence that tree resistance to cicada damage was higher when you had a diverse set of tree species. So this is really useful for suburban yards, because if you have a diverse set, you'll probably have lower damage by cicadas in an emergence year. And so you're going to support more robust food webs. And so these results matter for urban tree plantings or your yard as well, because we can kind of do a thought experiment where we think about, okay, a new development has gone in down the street. The developer is deciding how many different tree species to plant. Or we have a street tree planting that's going in, and there's a decision being made about how many different species to plant. And so you can imagine two different neighborhoods or yards, one where we have 5 species and one where we have 2 species of tree planted. So let's say species A, we've got 20% of it in one neighborhood and 50% in another. Let's say a species of invasive insect pest comes in that likes species A and is focused on eating species A. Now we have kind of a whole side of the street in one of the neighborhoods that is going to lose all of the ecosystem services associated with their street trees. Or in that development where they've only planted a couple different species of tree, now all of the trees have died at once. In addition to kind of these lower survivals, you'll also likely have fewer alternative prey and predators. And this isn't really a hypothetical scenario. We consistently have new invasive species coming in, such as the emerald ash borer, or right now, Asian longhorn beetle is a species that we have outbreaks of in South Carolina, in New York, in Massachusetts, and it will attack many of our street trees. So thinking about risk diversification is really important. All right, so planting a variety of species is going to be important for creating these pest-resistant landscapes. The other thing you can think about doing is layering biomass. So in a lot of our habitats, we see things like this. This is also true of yards. There'll be a native canopy, and then we'll get mown cool season grasses. And so there's a lot of empty space there. And so adding layers is important for integrated pest management because it creates habitat for those predators that we talked about, and parasitoids, and creates opportunities for alternate prey. So here's an example of my in-laws' yard in 2010. Kind of this mown situation with some canopy trees. And they added a lot of biomass over the last few years, and have found that they have a whole variety of alternative prey and have not had major pest outbreaks. So I'm not going to show data for this, but there's plenty of data you can look up about how canopy complexity is really important for generating pest-resistant landscapes. Okay, and the last piece I'm going to talk about briefly is more focused on suburban habitats, which I thought might be relevant for you all as master gardeners. And this is to really think about the life cycles of insects and how that intersects with kind of your garden care decisions, because that can have impacts on integrated pest management. So people usually tend to notice these kind of flashy and mobile life stages of insects, or when they're kind of eating garden plants in general and feeding down on things that we want to eat. But these insects are really leading pretty complicated lives. They have to hatch out as an egg. They go through a larval stage, eating the hosts of trees. In this particular case, this is the Luna moth, and it will actually pupate in a leaf, fall down to the ground, and overwinter beneath the tree in that leaf before emerging as an adult. And so this stage of where they're overwintering is a very vulnerable stage for a lot of these insects. And different species overwinter in many different locations, in soil chambers, in fallen leaves, on the soil surface, lots of different spots. And so if you're trying to think about how to create these diverse habitats, I think it can be a little bit overwhelming. You can't actually kind of manage for all of these different species. Instead, you want to create the variety of habitats and decrease cleaning, and that helps you support a lot of these non-pest insects. And so the piece of data I want to show you is some work that our lab's been doing on a particular management strategy, which is the removal of leaves in the fall. And this is a major disturbance. It also takes effort to rake leaves every fall, as I'm sure all of you all know. So this is work headed up by a previous PhD student in my lab, Max Ferlato. He is now the state entomologist for the state of Maryland. So you may have run across him as he's been doing work around the state. His work was focused on fall leaf litter removal, and he honed in on this as a really important practice because more than 35 million tons of these leaves are removed from residential lawns each year. So this is a huge amount of biomass that we're removing from the ecosystem. And it also is important because this is the habitat that a lot of our native Lepidoptera, moths and butterflies, and parasitoid wasps are using to overwinter. So these are things that feed up in the trees during the summer, but then need this habitat close to the ground in order to successfully complete their life cycles. So the ways that leaf raking can kind of affect this is either direct mortality, if say the insects are inside the leaves themselves that fall down, or you can have indirect mortality because you're changing the soil microhabitat where these insects burrowed down and pupated. And so his research was really focused on 20 yards in suburban Maryland. Not as much in Montgomery County, but in Prince George's and in Howard County. And what he did was basically go to both low and high maintenance areas of people's yards. Low maintenance tended to be the back. And he would either remove leaves or leave leaves in these two different locations. He would do that in the fall, then in March put out these emergence traps, and then collect insects every 10 days that were emerging from these plots all the way through the middle of the summer. And he did this for 2 years. And this is what this looks like kind of in actual yards. And we put up signs so that people were not totally confused about what was going on in these yards. So his main finding was that, even if you've been removing leaves from areas of your yard for many years, if you retain those leaves in a single year, you can regain the function of support of insects. So basically, the yards where leaves were left consistently had greater emergence of moths and butterflies in both of the years that he measured. And this was true of both the high and low maintenance areas. So you also get more species that emerge from these yards where leaves are left. And you pick up some different traits of leaves. You can read the paper, but basically you pick up more leaf miners, larvae that are overwintering as larvae or overwintering in fallen leaves. So this makes sense, but nobody had really done any work to quantify this before. And he also found that many more spiders were using the habitat with the leaves than the habitat without the leaves. There wasn't as much of an effect on parasitoid wasps, But he got very different communities of parasitoid wasps that were emerging from yards that had left leaves versus ones that did not. So the summary here is that when you remove leaves, you're immediately decreasing your successful overwintering leps and changing the communities that remain. We also have a paper looking at the effect of this on soil decomposition and carbon storage. And so the overall goal here is to really create these continuous and diverse food webs. And one way you can do that is potentially by creating more habitat, overwintering habitat for your predators in the winter. And somebody mentioned that there was an article that just came out in the New York Times about Max's work. So if you want to check out more about that, you can read it. I think it came out yesterday. And then he also has published a couple papers on this, and these are open access and available to anybody if you want to take a look. Okay, and how to implement this, we can talk more about this in question and answer, but I do think it's not just about leaving the leaves, it's about effectively managing the leaves in your yard. So overall, these are some strategies that you can use to create these more pest-resistant landscapes. And as master gardeners, you're playing a really important role in all of this and creating a lot of benefits for Maryland by promoting increased environmental health and biodiversity in areas where we all live. So the take-homes from this talk that I want you to come away with are, you know, not all insects that you see are going to be pests. When we think about integrated plant pest management, we can think about integrating tactics to create pest-resistant landscapes to begin with, and your cultural practices, which species you plant, and your diversification are going to set the stage or the dinner plate for the pests that are there. Using native plants and the right tree in the right place, along with diversification and structural complexity, can increase the good bugs and the predators. And these can help in a lot of different garden settings. So ultimately, the goal is we're trying to grow trees that are going to be very big, but also produce benefits for humans for a long time. And with that, I'd like to thank all the folks who have supported this over the years. Many of them, I tried to call out some of the students who have done a lot of this work, but there's just a huge variety of people who have made all of this possible. And if you want to go to this QR code and fill out kind of a feedback survey, if you have other questions you want asked, that would be awesome too. And I'm happy to take any questions that folks have.
Okay, thanks, Karen. Let me see. I have to get my video back on here. I'm gonna check with see. Is it let's see who was doing. Was it Gina or
No, it's me, Steve. It's Sue.
Sue, you're gonna do the questions if there are any questions.
We don't have a lot of questions. It's probably the after lunch effect.
Yeah.
Carol Cosier did put the New York Times article on Max's research, a link on the Gardeners Connected, so we should see that. Here's the first question about, is it better to use a lawnmower to shred your fall leaves or leave them intact?
Yeah, so Max did kind of a sub-study to look at that, and I think it's mixed results. I would say that from the moth and butterfly perspective, shredding the leaves is going to destroy the ones that are pupating inside those leaves. However, when he looked at carbon sequestration in the soils, shredding leaves is playing an important role there because it's making that material integrated more quickly into the soils. So I would say that kind of depending on what you're after, shredding leaves can play an important role. What I would suggest, what I do in my yard, is moving some of these leaves to areas under the shade trees. So creating like tree canopies or tree shadows is what I kind of call them, where you can see some data on soft landings that focus on creating that drip line under those trees being kind of filled with leaves, and that provides a good habitat, and you can put shade loving native plants that will push up through the leaves effectively under those trees. So things like ferns, things like a lot of our spring ephemerals have evolved to basically pop up through intact leaves. You can, if you have a ton of leaves, you don't have to do all the same thing with all of your leaves. Maybe immediately when they fall, like the first set, you mow those. And then the second set you get down, you move those into your beds and use them with raking. I think the longer you wait to shred them, the more of a chance that a wandering insect is going to find them and use them as habitat. So if you can if you're going to mow, I would actually suggest shredding them sooner rather than later, because insects won't have picked that as a habitat. Does that help?
It does, and it prompted several more questions about what is the most reasonable timing strategy. Gather your leaves in the spring, gather them early in the fall.
Yes.
When you leave them on the ground, when's the least harmful time to remove them?
Yes. So when Max did his research, he collected the insects every 10 days. And one of the things he found is he just consistently got new insects coming out of the leaves. So basically, if you have already moved leaves to a place, insects have selected them as a habitat, they're going to be coming out for a long period of time. The longer you can wait linearly, the more insects you're going to get. What I like to do instead is manage them actually in the fall. So right when they're coming down, move them into new locations where they're going to be used. So raking them into a bed around a tree, having some kind of barrier, rocks or tree stumps around it to contain those leaves so they don't blow away. And then those insects, when they fall down from the trees and are looking for overwintering locations, they can find a safe spot, and then they're already there and they can just emerge in the spring, and you don't have to remove those leaves ever in the spring. They're just going to decompose, act like mulch. Does that help?
It does, and it has me rethinking what I do this fall, so thank you. Another question is, do you have any recommendations on how to control the spotted lanternfly rather than squashing them one by one? That seems kind of futile.
It's true, and I think that was kind of an initial communication when we first were having them pop up. But yeah, you're probably not going to impact the population that way. If you have what we're seeing with the spotted lanternfly is that everywhere they pop up, there's like a wave that comes through with exponential population growth. And usually that lasts 3 years or so. So they already have come through Philly, and Baltimore is about a year or so ahead of where we are in Prince George's and Montgomery County. And so my guess is that they're going to continue to increase for the next couple years. And then what we're finding is population drop off. In terms of management, so I'm chair of our tree parks and environment committee for my town. And so what we are implementing is trying to remove Tree of Heaven. That's actually going to be one of your most effective strategies. Tree of Heaven is Ailanthus altissima. It's a non-native tree species that is actually from the native range of spotted lanternfly. And it's their preferred host, and it helps them reproduce successfully. It also turns out they're sequestering toxins from that Tree of Heaven, and it makes them distasteful to predators. And so if you can remove those from your yard or surrounding areas, that's going to create less attraction. You can also scrape if you do have a tree that's just covered in one year. I would look for the egg masses, and you can scrape those off if you can see them, and that'll help decrease your outbreak the following year.
So there was a question about using leaves for mulch because they fall on the lawn, which has crabgrass, which is going to seed, and then it feels like you're spreading crabgrass throughout your garden beds. What do you advise?
So I would say it might depend on the type of leaf, the type of tree species. So this is actually, it's so much of a more complicated question than just leaving the leaves, right? I would say that if you have something that decomposes really slowly, like oaks or hickories or one of these really tough species, that the crabgrass is not going to effectively, like if you move those under your tree, they're just going to prevent those crabgrass seeds from germinating. So I wouldn't really worry about it in that context. Those oak leaves, they break down slowly, they will basically form a barrier. For fast decomposing species like maple, tulip tree, kind of those thinner leaves, you may have a little bit more of a problem. You could potentially try to mix in some of these slower decomposing tree species leaves with those to try to create more of a mulching effect. So that's one potential strategy. I will say that the fast decomposing species will often be gone fairly quickly from under your trees. So you
Where
could
does
also
black walnut?
you could also try to mow before the leaves fall to prevent that seeding of the crabgrass, so that you don't have to worry about kind of any seed rain once you're moving those leaves.
Where does black walnut fit in this? You didn't mention it as a slow deterioration.
Yeah, I would say it's a little bit in the middle. I would say it's more on the slower side. Black walnut is interesting because it has some chemical compounds that break down in the soil and can kind of prevent actually the germination of seeds. So for that species, I actually wouldn't probably worry about the crabgrass so much, because it can decrease the germination of some of these native species as it breaks down.
Would a big leaf pile be more or less useful to insects than a thinner layer?
Oh yeah, so I think it's pretty clear that you don't want to have piles of leaves that are deeper than maybe 2-3 inches. So basically when you pile these leaves up under, maybe you'll have like 4 inches, but it'll settle. And you want to have maybe only about 2 inches of leaves, max 1 to 2 inches. I would say a big leaf pile is problematic for a few reasons. The insects have to be able to um, come out of their pupa if they're overwintering as a pupa and fly away. So if you pile them too deep, they're not going to be able to successfully emerge. Also, you hear a lot about ticks in leaves in kind of the literature, and basically very thick leaf piles do promote ticks, but thinner ones that are like 2 to 3 inches in depth do not promote ticks. And so I would say that using strategies that are thinner piles is really the way to go, both from the insect perspective, but also from not attracting ticks.
Thank you. That concludes all the questions. And for all of us, thank you very much.
Awesome,
All right.
thanks.
All right, thanks, Sue. Hey, so we're going to sort of wrap things up here. I want to thank Karen and all our speakers today. And just remind you, if you were here the entire time, you can put in 3.5 hours for continuing ed. Just send that in on your VMS to Katie. And I hope to see you, most of you, if not all of you, at the Montgomery County Fairgrounds, where Andy's going to give his presentation. So we will try to post the recording online for you guys as soon as we can. We're going to try to kind of edit it, clean it up, and we'll try to make it available to everybody. And I'll send it a copy of this to our link to our speakers as well. So after that, guys, I'm going to conclude things here. Have a good day and hope to see some of you guys soon. Thanks very much.